distinguished Vice Rector, distinguished Deans, and distinguished guests. Welcome to the second day of the third International Space Economy, Space Law, and Space Sciences Symposium. This symposium will continue on the second day with 3 sessions. Second day of the symposium will start with the presentation of our guest, distinguished speaker, Professor Piero Benvenuti. And the title of his presentation is The Impact of the Large Satellites Constellations on Astronomy, Scientific, Technical, and Legal Aspects. Now, I would like to give the floor to the Professor Piero Benvenuti for his speech. Professor Benvenuti, can you hear us?
Good morning to everybody, and thank you for having invited me to talk to this important symposium. Only regret that I couldn't be in person with you as I had planned to be, but anyway, I'm glad to be able to talk about a topic which is becoming very hot these days, and that is the impact of the satellite constellation on astronomy. I will talk about the scientific aspect of this, the technical issues, and also the legal aspect that we are touching on this issue. I believe we are really witnessing a new area in space, a new era in the space activity. And it's a bit ironical, the fact that we astronomers are indebted to space technology that gave access to the entire electromagnetic spectrum. And as we know, starting from the middle of the last century, we had made enormous progress in the knowledge of the universe because of the possibility of observing the universe from outside the terrestrial atmosphere. And now, today, the same technology, space technology, is threatening the science of astronomy in several ways. Now, why this has happened? What has changed? Well, as you know, until recently, the space activities was the domain of national and international space agencies, and they had as a goal the scientific technological advancement and the space exploration. But today the situation is changing because we see private companies having the same capabilities that until a few years ago it was the domain of the space agency. They can not only build a satellite, but they can launch and operate them in the same way as the space agency had done in the past. However, the main goal of these private companies is the economical profit. And this is the so-called new space economy. It's probably an inevitable evolution of the situation, but this is posing new threats, not only to astronomy. There are several issues that are coming obvious and evident by the new evolution. But I will concentrate only on the impact on astronomy. And this new situation is calling for new innovative mitigating measures, quite different, for example, from those that you may be applying to protect astronomy from the light pollution, the so-called artificial light at night, or olan. That require no regional regulation, but when the threat comes from space, as we are seeing this from the satellite constellation, what is needed is international agreement, which is quite a different story. And I consider this new impact of the constellation as a first example of the possible threats that will come from the new space activity. So we have to be prepared to new challenges. Now, what is the main reason why this is becoming a threat? It is the enormous increase in the number of satellites. Satellites have been there in the sky since several decades, as we know, but the number of them was limited. Until 2019, for example, we had a bit more than 2,000 active satellites in orbit. And after a couple of years, they were more than double. and now they are even larger. And you see in the graph the very steady increase in the number of satellites. Mainly these are the communication satellite. In particular, in blue, you see the so-called Starlink satellite of the SpaceX company. And what is really disturbing is that the projection in the future is very, very alarming. If we look at the requests that have been submitted to the authorities that give authorizations for the satellite to operate, like the American FCC and the International Telecommunication Union, or ITU, there are more than 400,000 applications. Now, not all of them will be obviously built and launched. However, even if the number reaches the few tens of thousands of satellites, the impact will be extremely serious. Why is that? Because these satellites, which are orbiting in the so-called low Earth orbit, that is between 350 and 1200 kilometers, for most part of the night, or even for the entire night, depending on the season, these satellites are illuminated by the sun, and so they are visible. Some of them will be visible by the naked eye, but all of them will be visible by the telescope, by the professional astronomy telescope, but also from amateur astronomy. And so the sky, the appearance of the sky will be completely altered, and the astronomical images will be affected by the trace of the satellite. So it's a major change in the situation. You see here a typical example of the trace that you see on the right in a real image, and on the left you see a simulation of a Hubble Space Telescope exposure, 10 minutes exposure, as will be predicted when all the satellites will be in orbit. Obviously, not all the telescope and not all the observation will be equally affected, but those who have a very large field of view, like the Vera Rubin telescope, which will be coming operative in a couple of years, the impact will be really very serious. And not only the ground astronomy is affected. Here you see a number of examples of interference on Hubble Space Telescope images from satellites. And of course, not only the optical astronomy is affected, also the radio astronomy. This is not a new thing. The satellite emitting radio wavelength has been there since the start of the space activities. But what is really new is the real number of satellites that are becoming very, very large. In the middle, for example, you see an image of the microwave sky as it was a few years ago. You see very clearly the ring of geostationary satellites which are emitting radio toward the Earth. But those satellites are fixed in space, and they are certainly emitting microwave, but their interference is limited to the very small fraction of the sky. Now you can imagine that when you have a few tenths of thousands of satellites orbiting the sky will be completely full of emitting satellite, and the microwave sky will be very bright. Therefore, for example, all observation of the cosmic microwave background, which is very important for understanding the early phase of the universe, will be affected and will be actually impossible from the ground. And here you see a clear example. As I said, the satellite is not a new thing. There have been not so many in LEO orbit, and many of them were located in geosynchronous orbit. But the situation is changing dramatically. Here you see how many satellites will be visible by radio astronomy when 5 of these constellations will be deployed. And it's quite different from the optical impact, where the image is limited really to the satellite illuminated by the sun. Here you have an active emission from the satellite. And as you know, the radio emission is not limited to the main beam. You have also emission in the so-called side lobes. And so the interference can be of various type. You can have a beam-to-beam interference, and that is the most serious interference that you may have. Actually, this is very dangerous because it can really even destroy your receiver if the emission is very strong, and that should be really avoided. But you can also have an interference coming from the side lobes, even if the main beam of the satellite is directed away from your observing dish, you can have still some interference. And the same is true if the main beam of the satellite is entering into one of the side lobe of your antennas. So you have various situations which is even a bit more complicated than what is happening with optical astronomy. And so the mitigating measures are, in this case, of a different nature of what you can be implementing with the optical interferences. So all this is I just described very briefly what are the impact and what is the impact that you can see and the threats. Now, what can we do? I'm describing now what the International Astronomical Union is doing. As you may know, the International Astronomical Union was founded more than 100 years ago in 1919, and today has more than 13,000 individual members from about 80 countries in all the world. And the main mission of the Union is to promote and safeguard the science of astronomy in all its aspects. And of course, we couldn't have remained inert in front of these new threats. So we decided to take two lines of attack. One is to make use of the fact that the International Astronomical Union is sitting as permanent observer in the United Nations Committee for the Peaceful Use of Outer Space. And that is a committee that is regulating all space activities. It is composed by now by more than 100 delegations from 100 countries. And so it is the authority that regulates the space activity. We know by experience that obtaining some regulation there takes a long time. So although we will pursue that, and I will describe what we have done so far in a moment, we know that the result will take several years to become effective. And so we also decided to take a more pragmatic and immediate action. And that was the creation of the center called CPS in short, which is the Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference. Now, there is one line which has been explicitly not endorsed, and that is to take possible legal action against the private companies. We know that this is still pursued by some astronomical minorities, but as IAU, we decided that that was not effective, and it was actually against the logical evolution of space technology, which has some obvious benefit. So, in short, what is the center doing? We like to unify all voices of the astronomical community with respect to the protection of the dark and quiet sky. So we are bringing together astronomers, industry, and the wider community. And we are discussing all together what is the best action that we can take to mitigate the effect. So we are collecting and producing and disseminating information, and anybody who wants or need this information can access that. We are really open to free collaboration, and we want to share all the information to everybody. This is not an easy task when we are discussing with private companies, because in some cases they really would like to maintain some information private and protected. but the spirit we are endorsing is this one, open and free. So the structure of the center, you can see we have two, I am the director of the center, and I have two co-directors, Connie Walker, who is working at the NOIR lab in Tucson in Arizona, and is dealing mainly with the optical and infrared interference. And Federico Di Bruno is working in Manchester at the Square Kilometre Array Observatory and is dealing with the radio interference. We have 4 areas of activities. We call them hubs: the SAT hub, the policy hub, industry and technology hub, and community engagement hub. And I will describe in a moment what these 4 areas of activities are doing. And there you see the name of the leaders of the four hubs. We are relying on the work and support of a large number of external members. So the center is essentially a coordinating center that is coordinating the activity of this large community, which I will describe in a moment. Here you see our strength is really the members that are collaborating with us. We have now almost 280 external members, and you see in the time evolution that the number is increasing every month. And I'm happy to see in the audience one of our member coming from Turkey, Itir, and I know that she's interested mainly in the legal aspect, but I encourage anybody of you want to collaborate with us or even being just informed to join the center as a contributing or affiliated member. Now, I give you a very quick description of the activity of the 4 hubs. And I will start with the satellite hub. The satellite hub is mainly concerned with the observation of the satellite, both in optical and radio. And this is actually very important because we want to give to the companies information about how bright their satellites are and what are their position. And a very important area of activity is the orbital solution. This is aimed to provide anybody with a very accurate position of the satellite. If you have that information, you can plan your observation in such a way that you can avoid the trail of the satellite crossing the field of your observation. In order to do that, you have to have this information very up-to-date and very accurate. At the moment, the public information that is available is not enough, is not sufficient for obtaining this, and so we are working very actively also with private companies to provide this information as a service to the astronomical community. And the group is also working on collecting various software tools that can be used to either make simulation or to remove the trail of the passage of a satellite in the image in case this cannot be avoided. And of course, we are also training people in doing this type of activity if they want to join the group. And recently, we have organized some observing campaign very successfully for some new satellite for which we needed to have the information about the optical luminosity. The policy hub is dealing with the legal aspect. So we are collecting all available space law and policies, both at national and international level, and to give just a global scenario. And we are creating a so-called position paper where we state the problem and we analyze it from the legal point of view. And of course, all this information is used then by the IAU when we participate in the meeting of the Committee for the Peaceful Use of Outer Space in Vienna. I'll come back to that in a moment. We're also involved in a very interesting initiative by the Swiss, by the Lausanne Institute Polytechnique, which is the so-called sustainability rating, space sustainability rating. They are starting a project to evaluate the so-called space sustainability of any space activity in the long term. And we are happy to have now astronomy included in that rating, and we are working actively with them to evaluate for any space activity what is the impact on astronomy. And there you see other activities that the group is doing, and it is a very active group, and if you are interested, I welcome you, I encourage you to join it. Then we have a community engagement and group, and that is has aim to inform the society at large about what is happening in the sky due to the constellation, and collect the information of the reaction of the people, and particularly of minority communities, about what that means in terms of their cultural heritage on the sky, because the sky is changing, and this may have an impact that goes beyond science, and that we want also to collect and to share that information with everybody interested. And finally, we have the Industry and Technology Hub, which is directly interacting with the space industry and companies, sharing the information and creating new mitigating measures that are effective and feasible from the point of view of the companies. And we want to share that with new companies that are now planning new constellation. We know there are several of them. At the moment, the most active are SpaceX, the Elon Musk company with the Starlink constellation, Amazon Kuiper, another American company, and the OneWeb, which is UK-based constellation. But we have more than 12 additional entities that are, or companies that are planning the constellation, including the European Commission that is now planning the IRIS-2 constellation. Some of them are not very large constellations, but the cumulative effect is what is really affecting astronomy. So we have to take care of any constellation now. We are encouraged by the fact that some of these new companies are becoming aware of the problem well in advance in terms of designing their constellations. So it is much easier for them to implement the mitigating measures that have been experimented so far with the current companies. So this is the scenario that we are creating now. I will be touching very quickly the legal aspect. So what we are proposing to have regulated. Well, there are three items where we can try to propose regulation. One is to make the satellite less reflective. The best goal that we could achieve there is to make them invisible to the naked eye. And that means that the satellite will not have any effect on the naked visibility of the night sky. So we are protecting, if you like, the cultural heritage of the pristine night sky. The second very important regulation will be to be able to predict the satellite pollution very accurately and make it that accessible to everybody. This is possible, certainly possible, but not easy to achieve because some of the company are quite resistant to share this information. You have to understand that by now, this communication satellite constellation has an importance which is going beyond just the pure connection. They've been used for several reasons and in several occasions, even in a situation where there are conflicts. And so the attention, the geopolitical attention to this constellation is very high at the moment. And so private companies are not so keen to share every information that they have available. And so this is a very delicate aspect that has to be discussed at the international level. And for the radio, the only possibility to avoid the interference is to ask the company to interrupt the emission, the transmission, or deviate that when they are passing over the major radio astronomical observatories. Fortunately, these major radio astronomical observatories are not as numerous as the optical telescopes. And so we believe that this is a measure that can be implemented if there is goodwill from the company. And so far, they have expressed the intention to adhere to this operational restriction. And of course, the International Telecommunication Union will continue to protect the wavelength bands of radio astronomical importance, and that is something that has been a long history. Now, I'm coming now to what we have been doing at the level of COPUS from the legal point of view. We started in, just for your information, I mean, this Committee for the Peaceful Use of Outer Space has two subcommittees, the Scientific and Technical Subcommittee and the Legal Subcommittee. And so far, we've been working mainly on the Scientific and Technical Subcommittee. We started in 2020 by making a technical presentation of the situation. It was just beginning to be seen as a problem. So the purpose there was to raise the attention of the committee to the problem. Then conference room paper presented by a number of delegations, Chile, Ethiopia, Jordan, Slovakia, Spain, together with the International Astronomical Union, with the European Southern Observatory, and the Square Kilometer Array Observatory. And we got positive support by 18 delegations, and we achieved the important goal that in the next STC, Scientific and Technical Subcommittee in 2022, there will be a dedicated agenda dedicated item, in the agenda of the meeting. And then we presented a working paper with a delegation that you see there listed. We had 25 interventions in support by the different delegations. We obtained a very important goal, which astronomy is now being recognized and as instrumental to all space activities, and therefore the protection of astronomy it is legally within the COPUOS responsibility. It was recognized that the impact of the constellation is serious and required the cooperation of all stakeholders. And the dedicated item will be maintained in the agenda of the next year, which was actually happened. In fact, this year, in February, we presented a new conference room paper for the protection of dark and quiet sky. And that was presented by Chile, Spain, Slovakia, Bulgaria, the Dominican Republic, Peru, South Africa, and of course, the Astronomical Observer, IAU, ESO, and SKO. And there were two proposals in this paper. One was to keep the dark and quiet sky agenda item for a minimum of 3 more years, to continue the discussion formally about the problem, because we see the problem is evolving very rapidly and we need more discussion to achieve some regulation. And the very important was the proposal to create a COPUOS expert group on dark and quiet sky, so that this expert group, which will represent the delegation participating in COPUOS, will proceed presenting possible voluntary guidelines to be followed for mitigating the impact. We got the support of more of 40 delegations, which is a large number, almost 50% of the delegation. Unfortunately, the Russian delegate objected to the creation of the expert group. He recognized the importance of the issue, but it proposed to continue the discussion within the existing working group on the long-term sustainability of space activity, which is a very large group, and it's proceeding very slowly. So we believe that that would not be very effective. We've been discussing with the Russian delegation during this period, and we hope that when the real couples will meet in June, next June, they will be agreeing on the creation of this expert group. So from the legal point of view, we should expect that the discussion will take place in couples, and we hope that some of these regulations that we are now discussing will be presented and agreed in time for the new constellation, for the new company to consider this regulation in the design of their new constellation. And I just want to conclude that we are welcoming your participation. You are encouraged to join our large group of members that will allow you to not only to contribute to our work, but also to keep you informed about the situation and be prepared to continue to work in astronomy in a way that is not affected too deeply by the new activity in space. So I thank you for your attention, and I'll be very happy to answer to any question that you may have.
All right, okay. We would like to thank Professor Benvenuti for his presentation. I guess we have a question online, so if you can allow to ask the question to our participant.
Professor Benvenuti, hello. This is Dr. Tsirtoxas. Very nice to meet you in person.
Nice to
today
meet you
I'm joining
too.
from my apartment because I have a class in about 15 minutes, but I have been on the symposium yesterday and I will be there this afternoon as well. As an affiliated member of your center, I would like to ask you, how important do you think is the public awareness on this issue? And what kind of activities would you recommend for raising the public awareness so that not only the stakeholders or the decision makers, but also the public at large would be, first of all, aware of the problem, and then maybe put some kind of pressure on the decision makers to move forward as well? I know that, for example, Turkish Space Agency is pushing forward towards establishment of parks of recreational areas of observation of dark skies, so that families can go picnicking or camping with their children and so on, to kind of raise awareness. And that the last time I heard, they were actively looking for such venues to establish within our country. But what more could you say about the public awareness aspect? Thank you.
Thank you very much for this very important question. Indeed, we consider that public awareness is very important to create knowledge about the situation. I mean, the situation is evolving very rapidly, and the society is not yet aware of what is to be expected. And as you correctly said, there are many areas in the world, and I'm happy to hear that also in Turkey this is taking place, that are creating the so-called oases for the observation of the night sky, which is a very important heritage, cultural heritage, that has to be protected. But of course, if this visibility of the sky is affected from space, it's not easy. Even if you create an oasis, then it will not be protected if there is no protection from international regulation. So we have a dedicated group, which is the so-called community engagement group, currently is preparing the so-called Astronomy 101 set of presentation, both in terms of slide presentation and video presentations of the situation. this is a quite important project because it's very comprehensive. It's made by a number of experts in communication and by experts in the field. So it will be also very authoritative, and it will be offered to anybody who want to use it to disseminate the information among the society at large. So this is has started to be really effective a couple of months ago, and very soon we will have this product made available to everybody who want to use it, and we will encourage actually the community to use that, and even to translate that. That will be, of course, made initially in English, but we will welcome anybody who would like to make a professional translation of this material in a language that is more accessible to the community they live in. And we are actually collaborating with one of the office of the International Astronomical Union, the Office of Astronomy Outreach, which has also some experience in doing that for astronomy in general. And so we are including now the impact of the constellation among this the subject of this dissemination activity, which is very important. And if I may, I would encourage the Turkish Space Agency and the delegation of Turkey in Kopos to sustain our activity, because the more delegation we have on board, the more effective our action will be in trying to have some regulation. As you may know, obtaining international regulation in this aspect is not easy, because the interests are well beyond the scientific interest. They are geopolitical, they are military interests, they are economical interests, and so achieving international law is very hard. As you know, the Outer Space Treaty is dating back in 1967. So, it contains actually some note that can be used, because they say there, it says that any negative impact created by a nation to another nation in space has to be made responsible for that. But how to define exactly the damage in such an area is not easy. So we are aiming to obtain some voluntary regulation or guidelines or best practice guidelines to be presented. But the more support we get from the regulation, the more effective will be this. So I encourage everybody to participate and to inform the society about what is happening, which is really dramatic and changing in a very important way the way space is used, and has to be protected. I mean, I'm always making the example of what happened with the introduction of plastic, which is a great technological achievement, but we know very well that by not understanding the need for a proper disposal of the plastic object, we have created a massive impact, negative impact on the environment. And we should learn that also for the space environment.
Very much. Thank you.
Thank you.
Thank you. And I would like to ask if there is any other questions. No. And I believe we have one another. Oh. All right. We do not. All right. Then we would like to thank again to the Professor Piero Benvenuti for his presentation. Now, I would like to invite the Dean of Faculty of Science, Professor Dr. Tansel Ak, to chair the next session. A total of 5 papers, which 2 of them will be online, will be presented in this session. Now I would like to present the valuable researchers who will present their papers in this session. Deniz Yazıcı, İbtisam Ahmet, Süleyman Fişek, Sayman Manzur, Sabiha Tuncel Güçtekin, I'd like to invite them to present their papers.
Hello, Assalamu alaikum. Should I go ahead to present my paper?
Just a moment, please. Just a moment, please. Now I would like to give the floor to the session chair, Professor Dr. Tansel Ak.
Okay, thank you very much. So as you said, we have 5 speakers, 5 presentations in this session. And the first presentation is titled Earth 3B Laboratory and its Applications, and it will be presented by Deniz Yazıcı. Each speaker has 15 plus 1 minutes. For the plus 1 minute is for discussions. So I am expecting them to finish their talks in 15 minutes.
Thank you so much. Öncelikle bu sunumda ve öğleden sonraki sunumdaki hocalarım Cengiz Yıldırım, Tolga Görüm, Orkun Özcan ve Yusuf Gedik gelemediler. Maalesef yakın zamanda yaşanan deprem felaketinden dolayı hala bölgede ve çalışmaları devam ediyor. Özürlerini ve selamlarını ilettiler. İlk önce bununla başlamak istedim. I'm Deniz Yazıcı. I'm PhD student at İstanbul Üniversitesi. Today I am going to present our 3D Earth Modeling Laboratory. First, I am going to talk about the remote sensing. Remote sensing is the process of identify and keeping track of an array physical process. Remote sensing determines the composition and nature of the surface and atmosphere of solid planets and change by analyzing image taken at different times. Satellite technology has given us a way to understand our planet and maybe universe. In optical satellite image, infrared and thermal bands make it possible to conduct comprehensive time-dependent working study area. Inside satellite image, distance between the receiver and the surface calculated by measuring the distance of the reflect radar signals, and such as digital elevation model and ground displacement maps to produced. Optical and SAR satellite image are processed in ORLAB, vegetation index, water body, geological maps, wildfire analysis, flood analysis, and such as landslide analysis, earthquake damage assessment, and many more can be carried out via optical and satellite image. Through SAR satellite image, ground displacement maps and surface velocity maps can be generated. Advances interferometric SAR method could determine the displacement in the ground on millimeter scale. UAV allow for much more detailed analysis than satellite, and observe it smaller scale. Optical and thermal camera mounted on UAV monitoring and performing monitoring and mapping, thermal mapping and 3D Earth modeling of the study area. The computer that we process data from in our laboratory are listed here. There are 1 fixed wing UAV and 10 multi-copter UAV in the laboratory. Optical and the thermal imaging UAV system are available. Data processing is carried out in the laboratory with licensed and open source software. This hardware, again, this computer that we are process and data from in the laboratory. remote sensing such as application river basin management provided data after a natural disaster, deformation measurement, archaeologic fields damaged by the fire determination, determination of the vegetation types, 3D modeling, or VR online presentation. These several TÜBİTAK and İTÜBAP projects are carried out in our laboratory. Some of them are shown here. Now I will show some UAV research carried out by Earth 3D Lab. First, monitoring the river floods using UAV and different times. Another study monitoring the wildfire in Manavgat due to the difficult to reach from the ground in the wildfire. Monitoring can be carried out using again UAV in forest area. Time-dependent change in dune deltas can be monitored using drones. Time-dependent change amount of accretion and erosion can be determined. Again, by determining the difference in digital elevation model produced by orthophoto using drones, subsidence and uplift on bridge can be determined. Damage assessment caused by human activity or natural disaster can be carried out. Another study monitoring the ground displacement change on the railway using UAV. By generating digital elevation model in different time series using UAV, change on the ground can be detected. According to change, railway structure can be analyzed and make an estimation of the possible determination in the future. Monitoring the change, the shoreline via optical camera mounts on UAV. Thermal monitoring is critical to observe climate change. Land surface temperature can be extracted via thermal camera mounted on UAV. Due to the sand dune on the shore coming into contact with seawater, the surface temperature may change depending on the moisture content. This change can be monitoring using UAV. UAV paved the way in archaeological study. We are working with Gonca Arıkan İstanbul Üniversitesi Archaeological Department. This photo can be taken with the UAV for each phase in archaeological study, and measurement can be made from the excavation sites points with precision gauges. In archaeological research, 3D point close, orthophoto maps, digital elevation model, and 3D model of each phase can be produced with the taken picture. This area, Badem Ağacı Höyük and Kuruçay Höyük. This video shows the 3D model of the İTÜ campus. 3D model can be produced using UAV and can be present of and product obtained with VR application. Drone simulation is the behavioral modeling of the drone or unnamed aerial vehicle and evaluating its performance in a virtual environment. Ayasofya 3D model generated by Earth 3B, and it is presented to user fly over the Ayasofya. Other UAV flight simulation over the Cappadocia. This is the last video about monitoring using UAV, a flight simulation over the Salamis Antique Amphitheater. It's can printed 3D application. Many studies carried out by our laboratory team have been published. Some of them are shown here. bu videonun açılması gerekiyor ama ben... This year we started new study on planetary geology. We are processing topography image of RAW taken from satellites on Mars. I can't show right now because the process is still going on computers in lab. It will be available everyone when finish it. I hope we will be here again next year with a presentation this subject. Thank you for listening.
Thank you very much. Any question or comment? Okay. Thank you very much, Deniz, once again. And the next speaker is Ebtisam Ahmet. Ebtisam Ahmet will present his presentation from Zoom. Can you hear us, Ebtisam Ahmet? Is there anyone who is trying to contact with him or her? If we cannot contact the speaker, we can jump to the next one. Tolga'dan bir haber gelsinler. Okay, we are jumping to the next talk. The next speaker is Süleyman Fişek. His presentation's title is Investigation the Effect of the DAG Adaptive Optics System on Galaxy Studies. Okay, Süleyman.
Good morning, everyone. I am Süleyman Fişek, PhD student at Department of Astronomy and Space Sciences, Istanbul University. And first of all, I would like to thank you for this opportunity to committee. This is actually my PhD thesis. We are still working on with my supervisor, but we would like to present our motivation, goals, and very early results. The Eastern Anatolia Observatory will be biggest telescope in Turkey very soon. It is located in Erzurum, Karakaya Summit, almost 3,200 meters above the sea level. And all Turkish astronomers, we are very excited to use it to observe a distant and more faint object. The observatory has 4-meter primary mirror telescope. It is the biggest telescope in Turkey right now, and also it has really important technologies. We call it active and adaptive optics. The technologies makes the telescope different to other 4-meter telescopes. With these technologies, the telescope will be very efficient. And also, the telescope brings us new observation opportunity because it will capability to observe the visible wavelength and also infrared wavelength. And DIRAC is the telescope's infrared detectors. Maybe the next session, Dr. Onur Keskin will talk about adaptive optics more detailed than me, but it is a really important part of my work. So I can say that just the adaptive optics system can improve the observation quality, doing correct wavefront comes from object, but negative affected by atmospheric turbulence. So the adaptive optics system, very important technologies, and our work, our study, we focused on the adaptive optics effects on the galaxy studies. In literally lots of simulating codes and programs using for the telescopes, particularly for the new telescopes, big and survey telescopes and space telescopes, before operational the telescopes determine limits and some performance analysis. As you see on the screen on the slide, two same images, but left one is actual images taken by CF Canada, France, Hawaii telescopes, but the right one, right side on the screen, is simulated image by SkyMaker simulated code. So, as you've seen, we can produce really realistic simulated imaging for the telescopes, images for the telescope, to improve operational parameters and also determine some limits and performance analysis before operational. So we will use we will use the SkyMaker or works. First, we choose a test target, Abel 2255 galaxy cluster, before jumping to scientific investigation and processing, because we would like to choose the very well-known target to compare our capability, and the SkyMaker is good for us for work. So we obtained the cluster data from data sets, Salonu'nda Sky Survey, and then we input the data, physical and photometric parameters we obtained from data server to SkyMaker as an input for each GRE bands, and then we have these three different simulated images by using SkyMaker, G, R, and E bands, pass bands, and then stack the each images. We have simulated galaxy cluster images by using SkyMaker. Left side and right side is real images. Of course, there is some differences because as Salonu'nda Sky Survey telescopes take directly image the cluster, but we use calculated parameters to generate the simulation images. But we saw that the SkyMaker is good for us and for works. Before the realistic scientific simulation images generated, we have some, how can I say, simulate the other parameters. For example, PSF, the astronomers as know very well. PSF actually say us the atmospheric effects or some kind of the effects on the image. So first of all, we have to PSF model generate before the scientific image to investigate the effect of the dark adaptive optics system on the image. Dark adaptive optics system parameters input the system, and then we have different PSF models for the dark adaptive optics system and some sort of atmospheric parameters, for example, seeing and wind speed, wind direction, some kind of how we can use we can use atmospheric turbulence layer, layer high, etc., etc. There is a lot of input parameters for the SOPI simulating codes for the PSF models. We generate these PSF models, different seeing value and also different wind speed, because of we have to simulate the different scenarios for the Eastern Anatolia Observatory. And then we choose 10 galaxies, and again, as we very well known, the cluster about 2255. And next step, we generated the realistic simulated images for infrared passbands J, H, and K, using the Eastern Anatolia Observatory parameters, Dirac parameters, and adaptive optic system parameters with atmospheric specifications and different scenarios. These are 10 different galaxies chosen by the Abel 2255 by us, H bands simulated galaxies. We focus first of all, we focus to analyze the images, obtain some information, the galaxies, to compare the real or data sets, parameters and information. One of the important things, galaxies, of course the magnitude is one of the most important things, the object when we observe it and want to observe the object. And also minor axis divided a major axis says the galaxy's morphological properties. So first we focus to obtain this data from our simulated images. When we run the, first of all, SOPI to generate PSF models, and then using the PSF models input to SkyMaker program to generate the simulated images when we see previous slides. And then we use sextractor, we use the sextractor to obtain and extract some photometrical and morphological parameters. First, we try to get some information about the minor and major axis ratio because of the galaxies' ellipticity properties show and compare. First five galaxies you can see from left side. First five galaxies, we have different scenario, seeing and wind speed scenario. The horizontal axis is wind speed, and the other axis is the morphological parameters. We try to get and obtain this data and compare the real scientific results. Of course, we have to improve our calculation and run style simulation image programs, but still it depends on some kind of come from the other input parameters, for example, detectors, new tests results, or some calculation or measurements, observatory site atmospheric properties. When it comes to new and different parameters to us, we put the program as an input to parameters and improve and better simulated images. And then we analyze the images we think we will have better results. In the next steps or future works, we will generate more scenarios. Depends on atmospheric and telescope and detector parameters, and also we run the codes for different type of galaxies, because I showed just elliptical galaxies to you because of the Abel 2255 has the elliptical galaxies most of, and then we
2 minutes left.
Okay, and then we will try to determine some limits. Eastern Anatolia Observatory, adaptive optic systems and performance. When we finish our work, we hope the work will be a guide for operators who use the telescopes and scientists who will apply the telescope to observe the objects. Thank you for your attention.
Okay, we thank Süleyman Fişek for his talk. Any question or comment? No. Okay. Thank you, Süleyman, once again. So, can Ebtisam Ahmet hear us? Ebtisam Ahmet. Yeah. Can you hear us?
Yeah.
Yes.
Yeah.
Okay.
I can hear.
This is your turn.
Yeah.
We are ready for your talk, and the title of your talk is a cloud detection methodology based on HSV morphology and cloud gradient analysis in satellite imagery. Okay.
Hello.
You have 15 minutes.
Yeah.
Yeah, we can start it. Okay. You can start.
Yeah. Bismillahirrahmanirrahim. Assalamu alaikum and greetings from Islamabad. I am Ebtisam Ahmed from Space and Upper Atmosphere Research Commission, Pakistan. I will inshallah present a cloud detection methodology based on HSV morphology and cloud gradient analysis in satellite imagery. Satellite remote sensing is used vastly for betterment of humanity. It has a lot of applications in environment protection, agriculture engineering, and many more. According to a modest study based on 10 years of modest data, 67% of Earth is always covered by cloud. So it is very important for satellite imagery to detect these clouds. Image processing operations are often complex and time-consuming. It is practically not feasible to perform image processing and later realize that there was no meaningful data due to presence of cloud. Thus, for any application, cloud detection is a critical pre-processing step. Based on working principles, cloud detection methods are classified into threshold-based and machine learning-based techniques. These algorithms work on the basic attributes of cloud. For threshold-based methods, these attributes are checked manually in satellite images. A relationship is then established between different image data parameters and cloud presence. This relationship is validated and tuned by using number of images. Once finalized, complete satellite images is classified into a cloudy and non-cloudy pixel. Similarly, for machine learning-based algorithms, these attributes are modeled, which are improved over time as more and more data is given input. Such techniques often fail in complex scenes with multiple ground targets. This is often the case for high-resolution satellite imaging. Current applications require frequent image acquisitions that are done by multiple satellites and not limited to one satellite only. Due to high resolvability, each satellite generates large datasets. Thus, use of practical and faster detection method is often a critical requirement. This work focuses on threshold-based methods which fulfills this requirement. Most threshold-based algorithms work by using multiple band information. Such information is very helpful as every band provides different cloud attribute information. MODIS provides 36 spectral band data, which gives multiple dimensions to cloud detection algorithms. One such cloud detection algorithm uses up to 7 bands, while another uses 5 bands. Official cloud masking algorithms of MODIS uses 14 bands. Similarly, Landsat 7 provides 12 band data. Automatic cloud cover assessment, which is official cloud detection algorithm, uses 5 spectral bands. Sorry about that. Thermal infrared band data is used extensively in such algorithms. This uses a very important attribute of cloud, that it has a lower temperature in comparison to ground targets. However, this band is often not present in high resolution satellite imaging, which is the prime focus of this work. This work uses Gaussian filter as a primary cloud detection technique. HSV and edge-lock filtering is used to remove false positive generated by Gaussian filters. This figure represents a general outline of algorithms which will be seen in detail in subsequent slides. Gaussian filter is done in grayscale image to save computation time. No efficiency is lost as a result of this gain. Low pass filtering is done that highlights everything in image having smooth boundaries, like forests and water bodies. This is also a critical cloud attribute. Absolute difference is taken between actual and low pass filtered image. Thresholding is done to get binary mask of areas where absolute difference is less than threshold. This procedure also highlights all the ground targets with smooth boundaries, like forests and water bodies. Another false positive is flat man-made, highly reflective targets, like parking lots and rooftops. Edge-log filtering is thus applied with goal of detecting man-made objects. It works on sudden intensity change detection that basically detects edge of buildings. These boundaries are filled morphologically based on assumption that most buildings and other man-made objects are enclosed. Intensity part of HSV filtering works on cloud attributes that clouds provides very high reflectivity. This removes any smooth ground targets with low intensity. Saturation of HSV filtering, which is the second part, works on cloud attributes that every cloud is gray with no color information. This removes any ground object that is not gray. Concrete man-made structures have already been removed by edge-lock filters. Filling morphological operation is performed similar to edge-lock filtering. Another assumption about cloud is made that these are not very small. Thus, any cloud detected within very few pixels is discarded. It may remove any such small clouds but based on their lower probability, this is incorporated for noise removal. Cloud detection is applied on 3 satellite images, Econos 2, Orview 3, and Sentinel-2 with varying GSVs. Thanks to USGS Earth Explorer and Sentinel-Sci web portals, these satellite images are freely available for general public. Sigma parameters is observed to be increased while Gaussian threshold decreases with GST. These figures depict original satellite images along with the Gaussian filter, water bodies and cloud shadows represents Gaussian filter outputs at different values of sigma. Lower sigma means include ground targets. Higher sigma selection will detect blur objects as clouds, providing better cloud detection. Optimum value is extracted for any satellite. Next is the edge lock filter. And just a minute. Yeah, in this edge lock filters, buildings are detected, and these are basically the anti-mask which will be subtracted from the original mask generated from the cloud. And these results show the HRC filtering results. And as seen earlier, these will remove the water bodies and like the forest, which will be removed externally. So the optimized threshold values of Econos 2, Orview 3 and Sentinel-2 satellites will be obtained, which will be trained by number of satellite images. Once trained, these satellites will remove these parameters will be applied to every satellite image. This shows the original Sentinel-2 image, and after the cloud detection, the clouds are detected and shown in the figures below. Similarly, Econos 2 and Orview 3 satellites have this results. Here we can see some problems like cirrus clouds are not being detected well. So cloud detection works well, but despite the problem that they don't have TIR band data. So two shortcomings are observed, that our algorithm could not differentiate between cloud and snow. Secondly, cirrus clouds are not detected well. These are not detected well, sorry. Did somebody said anything?
No, we didn't say anything. No.
Okay. So high resolution satellites also provides null data in addition to visual band data. So in the future, we are looking to use this null data, although it is not that efficient like TIR data, thermal infrared data, but still it will provide some useful information that could be used, that could improve our cloud detection algorithm. Now I will thank you all and welcome any suggestions and comments.
Thank you very much for your talk. Any question or comment?
Thank you very much.
Any question or comment?
Sure.
No. Okay, thanks again, Ebtisam Ahmed. Thank you very much. So,
thank you very much.
Our next,
and best of luck.
Have a nice day. Our next speaker is Saime Manzur. I hope I am correctly pronouncing the name.
Hello, Assalamu alaikum.
Alaikum salam.
Walaikum salam.
Okay, Saime Manzur, you can hear us, I presume. Can you hear us? Saime. Yes.
Can you see my screen?
Yes, we do. Yes, we can. You have 15 minutes. Okay, go on. Bizi duyamıyor galiba arkadaş. Saime, can you hear us?
Yes, I can hear you.
Okay, you can start your presentation.
I am Dr. Saima Manzoor from Sparko, Lahore, Pakistan. The topic of my research is the comparative analysis and experimental validation of gamma ray shielding performance of potential polymeric materials. So the table of content includes introduction, a little bit of introduction, selection of polymers, radiation attenuation parameters, the modeling and simulation method, sources of radiation used here to analyze the different polymeric materials and methods, and their results and discussion. research is to determine the best pristine polymer material to shield the gamma radiations which are present in different fields such as nuclear waste storage, for nuclear imaging and therapy, space exploration, and high energy physics experiments. So the choice of material for shielding depends on the type of the radiation which you are focusing. That is, if we are focusing the gamma radiation, then the effective shielding for the gamma radiation should be the material high density, and the higher atomic number of the material should be taken. Since the gamma radiation is very penetrating, so it must be shielded by the very dense material. For example, the lead, typical lead is being used as gamma radiation shield. There are certain advantages and disadvantages of this lead. The advantage of lead is it is dense, it is compact, and it has high atomic number and has stable isotopes. Whereas the disadvantages, the main disadvantage of lead is it is toxic material. It is non-flexible, and also the Bremsstrahlung production during the electron interaction is not suitable for us. So we can see over here the gamma, from the picture that gamma or the X, for the gamma or the X-ray, the lead completely blocks the gamma radiation, whereas as compared to the paper or the aluminum plate. So there is a requirement to choose a material which is comparatively less toxic or the cost effective and suitable for the gamma radiation. So the choice for the selection, there are certain materials which are being investigated very much, such as glass ceramic materials doped with bismuth oxide, lead, or different oxides of the material.
Excuse me, Dr. Manzur, are you changing slides?
Sorry?
Are you changing slides? Because we don't see any change in slides in your presentation.
Sorry, I cannot understand you.
No, we don't see any change. Evet. Ha. Can you check the chat box in your Zoom? Yes, now it is okay. Okay, you can continue.
Can you see screen?
Yes, we can.
Okay.
Yes, okay, you can continue.
Sorry for the interruption. So there are the research work which is being carried out for the different gamma radiation shielding materials are the glass ceramic materials, different composite materials with addition of metallic or the ceramic metals oxides, nanoclay fillers or the nanoparticles, and also the addition of organic fiber or the fabric along with metallic coating. It is important to consider factors such as the required attenuation level and the type of the energy for the gamma radiation shielding. So for choosing the material, specifically talking about the polymers, there might be thermoset or the thermoplastic depending upon the end use application. And secondly, after selection of the type of the material, the next level is the particular polymer depending upon the mentioned capabilities. That is, the material should be flexible, lightweight, durable, cost-effective, non-flammability, and must have the radiation resistance. So there are different attenuation parameters which are required to understand first for the radiation shielding. The first one is the mass attenuation coefficient. It is the measure of the probability that a gamma ray will be absorbed or scattered per unit mass of the shielding material. It depends upon the radiation, it depends upon the energy and composition of the material. The second one is the LAC, that is the linear attenuation coefficient. It is the number of scattered photons per unit length of the target material. The HVL or the half value layer is the thickness of the shielding material required to reduce the incoming gamma ray intensity to the 50% of the original value of the incoming radiation. The TVL, that is the 10th value layer, the thickness of the shielding material required to reduce the incoming rays intensity to 1/10 of its original value. So here the two simulation techniques are being used. That is first one is the phi-x and the other one is the WinXCOM. Both are the Monte Carlo based simulation techniques which measure the photon shielding and dosimetry calculations and different parameters of the shielding. So the results are in phi-x is the quicker one as compared to the WinXCOM, and the WinXCOM lately called as it was named as XCOM, developed by Berger and Hubble, recently transformed to WinXCOM, and it can calculate the attenuation data and the mass attenuation coefficient for the shielding material. So here the sources of gamma radiation emitters for analysis are being used are cobalt 60, barium 133 and cesium 137. So the polymers chosen for the recent project are the polyethylene, polydimethyl siloxane. These two are the low density materials, and the polymers used PU, that is polyurethane, polymethacrylate, and PBI, that is polybenzimidazole. These are the high density materials. So from here we can see the result of our simulation results, in which the MAC represents the interaction cross-section per gram. That is lower value of G results, higher MAC. Area of cross-section offered by the target material to the gamma radiation photons. From here we can see that as the energy increases, MAC decreases. That is, MAC is the mass attenuation coefficient is inversely proportional to the energy of the incident radiation. So energy up to 81 keV, the PDMS value is maximum, and after that 161 keV to 2.51 MeV, the polyethylene is found better. So best value is so we can say that the MAC is the lower value, higher value of MAC is the best shielding material. So lag represents the scattered photons in per unit length. Higher lag, more photons would be scattered. So PDMS has the higher lag. PDMS has the higher value of lag, then above till 53 keV, and then above 50. So lag of the PBI is increasing up to 2.5 mega electron volt. The TVL is the thickness of the target material that is capable to absorb 90% of the incoming radiation. The low value of TVL, more attenuation capability. So TVL of PDMS increases up to 161 keV till 2.51 mega electron volt. So TVL increase means MAC decreases. These are the interlinked properties. So PDMS minimum TVL is at low energies. So it is recommended for the low energy gamma ray applications, and PBI is used recommended for the high energy applications. This graph represents the mean free path of the polymer for cesium 137 and cobalt 60 isotopes. Mean free path is called as the relaxation length, that is distance between two successive collisions of incident photons with target materials. The lower the value of mean free path means higher number of collisions. It means that the higher energy loss of the incident photons, and at the end the higher attenuation is achieved. So the energy up to 53 keV, the PDMS has low value of mean free path, and at higher energies TBI has the low value of mean free path. So This is the comparison or table of the MAC calculated by using the two different softwares, that is WinXCom and PyX, and these results, we can see that these results are comparable to each other for different materials, and their densities are being represented over here. So the two different, according to our calculations, simulations, we have concluded that the PDMS and the PBI, these two are the materials, polymer materials, which shows the best shielding properties. So we done the experimental validation for them and made the samples for PBI and PDMS, and the experimental and simulated MAC of both the materials was incomparable with each other. So in conclusion, the PDMS polymer is good absorber for gamma radiation up to 53 keV and PBI for energies from 161 keV to 2.5 mega electron volt. So it is proposed that the PDMS polymer and PBI polymers are the best pristine polymer matrices for attenuation of gamma rays at low and higher energies respectively. So low density such as PDMS and PE, they require the addition of high density fillers to improve the attenuation properties so that they can be used for the higher energy attenuation also. So these are the acknowledgements, that is NCGSA, the National Center of GIS and Space Applications, and the SPARCO, that is Space and Upper Atmosphere Research Commission. Thank you so much.
Thank you very much. Is there any question or comment for this presentation? No. Okay. Thanks again, Saime Manzur. So, the last presentation of this session will be given by Sabiha Tunçel Güçtekin. The title of the presentation is Using the Gaia Database to Calculate the Luminosity Function of Thin Disk. You have 15 minutes, as I always say.
Okay, welcome dear guests. I'm graduate in Istanbul University Department of Astronomy and Space Science, and I studying in here Hacı Bayram Veli University in Ankara, Department of Physics. Now today I want to tell you about satellites shortly, and Gaia satellite, and our study with Gaia database, DR3 database. And satellites are very advanced for astronomers, and there are very kind of satellites, but important is there is Earth-based satellite and space-based satellite. Space-based satellite and is important at first Hipparchus, and important of them Gaia. I will tell you shortly Hipparchus. The first based astronomical mission telescope will be carried out by the Hipparchus satellite. It's shuttle into space in 1990. And Gaia satellites, after nearly 20 years later, Gaia satellites shuttled into space in 2013 years. And what is Gaia satellite? Gaia satellite, it has the name of Greek goddess of the earth, Gaia, who is regarded as the mother of all life. ESA Science Programs Committee has approved its 6th project. It's Gaia satellite. Gaia satellites At space area, space-based satellites are important for us, and Gaia is important for astronomers because Gaia satellites breathe about the space age's golden area, high observational quality, and in deep sky research, and it's especially successful because no astronomical effect in Gaia database. So Gaia satellite brought about the space age golden area. Now it's the satellites, Gaia satellites mission. It's Gaia satellites launched into the space nearly 10 years ago. During these years, sent to data from space. It's very big data, not only stars, all it's about Milky Way objects. Gaia satellite around the world 1.5 million kilometers away from the second Lagrange point of the Sun-Earth-Moon system has been placed at a very good location. There is largest CCD mosaic include. Gaia satellite has 106 CCD receiver. Satellite's mission, basic astrophysics concepts like effective temperature and surface gravitational acceleration are determined using the Gaia satellite, which also measurement velocity distributions in three-dimensional space of stars. And then to calculate Milky Way's attributes in order to better comprehend its composition, development, and evaluation. So Gaia data is important. And in here, Gaia data lies there 1, 2, or 3 images. Gaia data lies in all of them database include nearly 2 billion stars and very different objects, and include spectroscopic, astrometric, and photometric measurements. So we studied with Gaia database DR3. Now we want to tell you shortly my research. Aims to my research to obtain the space density at the solar neighborhood, and then to obtain luminosity function of the main sequence thin stars at the solar neighborhood by Gaia satellites. Yes, in here data using Gaia satellites database at last database. Total of number of stars nearly 42 million stars, and we are choosing in this catalog. We select this catalog has sensitive relative parallax error and were located with 1 kiloparsecs of the sun. And there are images, Hertzsprung-Russell diagrams. Images include wide spectral type and at left, apparent magnitude color diagram, and right absolute magnitude color diagram. This shows that not only main sequence. In right diagram in the red line main sequence stars thin disk, but other include white dwarf, giant dwarf, and red clumps, etc. Nearly in here 42 million stars, and then we started analyze in this study. In this study, method to determine the extinction value of the Gaia photometric magnitudes and dust maps of the Milky Way were used. When choosing main sequence stars, parsec isochrone of the thin disk population calibrated on the Hertzsprung-Russell diagram were taken in the concentration. At last, nearly 39 objects in main sequence band, and we were chosen as main sequence stars on the Hertzsprung-Russell diagram. In this study, stars in spectral classes very wide, A1 to M6, and have absolute magnitudes between 0 and 15. In here, at 2 is Hertzsprung-Russell diagram, and on the left, parsec iso-H curves, and right absolute magnitude in here, and red lined we selected our catalogs. Yes, results and from the main sequence stars located at a distance of 25 and distance 300 parsecs from the Sun. Results, the space density of the solar neighborhood was determined to be 0.072, and results 2. The analysis demonstrated compatibility between the luminosity function obtained up to 175 parsecs and with the relative parallax error and 0.1, and the luminosity function sublet for the distance value of 100 parsecs in the literature. And then is results table and graph in you can see, and table has absolute magnitude between 2 to 13 step by step we calculate from formulas with literature, and then results the compatible literature, so its result is good. And then this table given the luminosity function, different intervals and step-by-step absolute magnitude, and last table, and then given to luminosity function different intervals at 100 parsecs and 125 parsecs is same literature, and then 150 parsecs and 175 parsecs, and luminosity function is nearly same literature, so it's a good study in here. Result is very satisfied and it's compatible. Thank you for attention.
Thank you very much. Any question or comment? No. Okay. Thank you very much again. So, as we have gained some time, we can eat more in lunch. We have a longer time for lunch, so we will meet at 2 o'clock afternoon. Okay. Thanks.
Thank you very much. The session is over. Now, I would like to invite the Dean of Faculty of Economics, Professor Dr. Sayım Yorgun, to the podium to present the certificates of the participation to the presenters of the session. Thank you. Thank you for participation. The fourth session will start at 2 p.m. afternoon. We look forward to see you again in the fourth session. Thank you. Session of our symposium. In this session, we are going to listen to our guest speaker, Associate Professor Onur Keskin's presentation, which is titled Focal Plane Instrumentation for Space Sciences, Troya and Koray. And now I would like to invite Professor Keskin to the stage to make his speech.
Hello everyone. Shall I start? Okay. Okay, today I'm going to talk about the focal plane instrumentation at DAG telescope. But first I want to give a brief description about the telescope itself. By the way, did you move this or did I? Bu, sen mi oynattın? Kendi gidiyor bu. Ha, öyle mi? Okay. First, let's mention about DAG telescope and Eastern Anatolia Observatory's mission, vision, and values. The mission is to make competitive observations at international level, to offer opportunity for innovative technologies and support development of the current science. This is the mission of Eastern Anatolia Observatory, and the vision is to become a leader observatory that is preferred, that is competitive, at national and international level, and that directs space sciences. Let's mention about the infrastructure first. Well, the DAG is actually situated at Karakaya Mountains at 3,140 meters altitude. This is a high altitude plateau. The distance from the city and the university itself is about 35 kilometers, so that actually enables us to actually travel within 40-45 minutes from the university downtown to the telescope itself. The clear nights are more than 250 per year, so this is a very good site. The humidity is low, so this is as low as 2 to 10%, which allows infrared observations. We have a stable wind and low wind speeds, so the temperature values are as low as -35. That actually enables us to actually do near-infrared observations as well. And the good thing is that the atmospheric layer, immersion layer, is about 800 meters lower than where the observatory is situated. Erzurum is known to actually have quite a big amount of snow accumulation, but here on the top of the mountain itself, at the Karakaya site, we have less than 1.5 meters. Having said that, this 1.5 meters is usually accumulated on some certain corners and certain areas of the site itself. So on top of the telescope, we usually observe about 30 centimeters of snow, and that's pretty much about it. So the snow season is from November to April, and then we have a building which is actually built, which is operational. So the building itself actually has active and passive solar energy. The fact that near-infrared observations will be performed, so you don't want to have any heat ray signatures. So this is why it's a passive solar energy building. It is disabled friendly, and it is concrete and steel. So in the building, the observations, the computing, the coating chamber will be at the unit as well, which hasn't started yet as a project. And then we have an optical workshop, and the service building is accompanied. So these are the pictures from the starting of the infrastructure itself. First, the top of the mountain is actually lowered down in order to actually have a flat surface. So basically a lot of excavations have been performed, and then gradually the observation, the observatory itself, and along with this is the dome of the telescope that you see here. So this is within the years. Okay. So what we actually have is, I'm going to talk about some infrastructure as well in terms of electricity, in terms of power. So we actually have 40 kilowatts of UPS inside, and another 35 kilowatts mobile UPS, two 120 kilowatts UPS in the site as well. We have 800 kilowatts of generators, which is near the site. Lighting safety is performed. The internet has 48 cores and 100 gigabits per second. So this is a quite fast fiber line. In terms of transportation, we have 12 kilometers of asphalt and then another 25 kilometers. The last 7 kilometers of the observatory is stabilized. The fact that the site is actually used as a ski resort during winter time as well. Asphalt was not allowed by the government, so we just left it as stabilized road. We have 5 seismographs, and geological analysis survey is done. And the observatory, just in any case, is built as the best standards for the earthquake resistance as well. In terms of accommodation, Atatürk University offers guest houses. So these are 1 to 3 person accumulations, and there are 3 guest houses. Atasan building has accommodation in campus as well. The new building, Opal building, will be performed within the following years, but as it is, it only offers 2 rooms enabled for 4 persons of accommodation. And then the service prefabric building in the site has 3 rooms, which allows us to actually guest 18 people. And the DAG main building, the observatory building on site, will have 6 rooms, which will be double occupancy. So basically 12 observers will be able to actually stay on site during winter and summer conditions. If you want to have an observatory, what you need is to understand the atmospheric interventions first. So in order to do that, DAG has meteorological systems and astronomical systems as well. The meteorological systems are given as Davis-Weissel stations, Boltwood cloud sensors, meteorological systems, GNSS systems, and then as astronomical ones, we have 2 sky camera, 1 scene monitor, 4 rotating sky quality meters, and 1 mass dim system. It was planned to actually have a SLODAR telescope specifically assigned for the adaptive optic system, but it wasn't easy to actually collaborate at the time, both funding-wise and bureaucratic-wise with Durham University. But this is still on the site, and we hope to have a specific telescope which is dedicated only for the adaptive optic system itself. This is the observatory building. It has 2 floors, and the accommodation rooms are on the top floor, and on the bottom floor we have the computing rooms and the servers and main service building, and then basically the coating chamber will be also in the basement too. Most of you actually know what the DAG telescope is, but it's always good to actually give sort of an introduction about the optics of the telescope itself. It is 4 meters, well, when you actually, it is attached on the corners that actually hold the mirror, so the clear aperture, whether we actually mention it as 4, is actually 3.94 meters diameter, the clear one. The central obscuration is 98 centimeters, about 98 centimeters. The focal length is 56 meters. The exit pupil diameter is about 0.7 meters, and the M3 center to focal plane is 4.2 meters. So these numbers may not mean too much to non-astronomers, But what we can mention is that the DAG has the largest optical mirror in Turkey, and that the mirror, the coating is done in such way that it will allow both visible and infrared observations. It has two Nazmit platforms. One of them is already dedicated to infrared astronomy, near infrared astronomy, and the other one is possibly will be dedicated to seeing limited observations. This is the mirror, and this is further information about the telescope itself. It on one Nazmit platform, which is the seeing limited platform, it has 24 arc minutes of field of view. On the other side, which is the diffraction limited platform, it has a field of view of 7 arc minutes. The reason why we have less field of view on the diffraction limited side is because the adaptive optic system doesn't require such big field of view, and then additionally the encoders were placed in the Nazmit tube itself in order to actually allow a very smooth movement within the telescope. So the instrument capacity is 6 instruments. Including the derotator on the near-infrared side, we already have, if we can count the derotator as one of the instrument as well, then we have 3 plus the derotator on the infrared Nazmit platform. So the mounting is alt-azimuth. It is a Ritchie-Chrétien telescope. It has both active optics and adaptive optics, and it is one of the few telescopes. It was the only one, but now one of the few telescopes in its size and in its class to actually host both adaptive optics and active optics at the same time. So I don't know if you're familiar with the active optics, but this actually helps us to actually eliminate the gravitational effects of the mirror, because when the mirror is large enough, due to bending moments and due to the dynamic behavior of the telescope, sometimes we encounter problems due to gravitation as well of the mirror itself. So active optics is fully eliminating that feature. So the mirror type is zero-dur. It was manufactured at SHOT, so the manufacturing of the mirror itself took about 3 years, and then it was sent to Russia for polishing, which took another about 2 years, and with the coating about total it was like 5.5 years to actually order and receive the mirror, both from Germany to Russia and back. So the pointing accuracy of the telescope is 1.85 arc seconds, and the tracking accuracy is 0.1 arc seconds, RMS. The telescope is manufactured by Amos, but before it was manufactured, what we have done is in-house, basically, with the resources in Turkey. First, the performance of the telescope has been decided to actually be able to host the adaptive optic system, and then from that we went backwards to actually calculate the requirements of the telescope, and then it was confirmed by Amos, which is the Belgium telescope manufacturer, and it was tendered. EIE actually is taking the responsibility of doing. EIE has no part in the telescope itself, but it is a subcontractor of the Belgium company, so they are only doing the mechanical systems of the telescope itself. And then we have the enclosure, we have the dome. The specifications are that this is 16 meters in diameter and 18 meters in height, so in order to actually host a secure location and secure environment for the telescope. So it has active environment control, cooling systems, of course louvers and windscreens, and it is enabled with a bridge crane which is able to actually weight about 10 tons. And the manufacturer of the enclosure itself is the EIE corporation from Italy, from Venezia. And then, of course, we have the focal plane instrumentation. On the focal plane instrumentation, CORAI, which is K-mirror optical relay, is performed by OPAM in collaboration with ATASAM. Troya, which is Turkish Adaptive Optic System for infrared astronomy, is also done. It is an extreme adaptive optic system. It is also done by OPAM, but in collaboration with Atasam as well. Dirac is the diffraction limited infrared adaptive optics camera, which is tendered to AAO from Australia, and for, of course, near infrared observations. And then the coronagraph, SLM-based stellar coronagraph, is tendered to HEIG-VD University from Switzerland. So having these systems in the infrared range, so this enables us to actually have broad scientific interests, high definition near imaging, low mass stars, and exoplanet research. I'm just an engineer, so I'm just reading what the astronomers told me, okay? So don't ask me any questions on this. I'm only the guy that's trying to build the systems. But basically, these focal plane instrumentations will enable the characterization of studies of star formation in the Milky Way and nearby galaxies, as well as analysis intermediate and high redshift galaxies. So for these questions, you may ask Professor Yeşil Yaprak there. So I have no idea what kind of information that I could actually share with this science objectives. So then I'm going to mention about the Koray and Troya, which is built in-house at my university, at our research center, of course, again, in collaboration with Atasam, because we needed to actually have advisory directions, because these are the astronomers that will be using the system, and we actually play the role of engineers that are building the system. So it is a K-mirror system. So what happens is, if you don't have mechanical rotators or derotators, you have to dedicate the rotators themselves for each and every single astronomical instrument. So here the derotator is actually inserted in the Nasmyth flange of the telescope itself, and at once it actually enables all scientific instruments to actually benefit from the derotation capability of the system itself. So in this sense, this is actually a first, and on the next slide I'll show you that we have 2 European and one world patent application for that, which is resolved but it's not published yet, which is accepted so far. So basically the rotator is going to calculate its rotation to counteract the movement of the Earth itself and the celestial objects too. So it takes the information from the azimuth and altitude axes of the telescope, so it's in direct contact with the telescope control system, and via EtherCAT systems, so basically via TwinCAD and EtherCAT systems, we receive this information instantly, and within 2 milliseconds, the rotator starts itself. The rotator range is plus or minus 170 degrees. But the rotation speed is very slow during observations and especially during tracking. So this is an example. For example, if we are at an elevation of 85 degrees, the derotator has a speed of 0.02 degrees per second, whereas when we actually reach the angle of 89.9 degrees, then the maximum rotational speed is 1.1. So here what we actually provide to the astronomers is that we have a rotational speed contour plot. So at which elevation the astronomer wants to actually go with the telescope itself, they will pre-know what is the calculated of the rotation. But as you can see, at maximum speed, and usually astronomers do the observations at almost 89.9 degrees in elevation. So basically around 80 degrees itself, so the rotator range is 170 degrees, so multiply that by 50, you have enough time to actually have the full derotation. But if the astronomers would actually require to go to another target, for example, so at that case we have a homing position, we have 3 modes, the engineering mode, the tracking mode, and the homing mode. So basically before doing the observations, if you're going to switch to another celestial object as a target, then the rotator actually gets back to its home position and restarts. This is the rotator which is built. The fact that the telescope is there, the optics of the telescope are installed, but the first light and optical alignment of the telescope itself is not achieved so far. So this year, either the 30th of August or 29th of October, so which is the biggest two national days for Turkey. So basically we are planning to actually have the first light. So until the first light is achieved and until the Nazmit platform itself is secured from light, wind, dust, we have a certain enclosure that is built for that, and we have done the design and we will do the control of the manufacturing as well. We have kept the rotator and the adaptive optics systems which are built in Atasam laboratory, but we have fully characterized them, of course, and this is the physical shape of the rotator itself. So this is as built rotator. As I mentioned, there are 3 patents that are accepted and which we are waiting for the publications. And then the Troya, which is the adaptive optics system. Do we have pointer in this? How do I get back? 2 tane geri gidebilir miyiz? Slaytlarda. Ben orada anlatırım. Slaytlarda 2 geri gidelim. Bastıkça ileri. Ha bir dakika. Tamam. Yeah. Okay. So on the right hand side you're going to see the Zmax model of the Troya system, and on the left hand side you're going to see the 3D mechanical model of the Troya system itself. So basically we have 468 actuators. So in terms of performance, the 468 actuators will actually give a strail ratio up to 80 to 90% strail. So which is almost very close to the diffraction limit of the telescope itself. And the fact that we are using a pyramid wavefront sensor on Troya, so we don't have the limitations of Shak-Hartman wavefront sensors, undersampling and measurement range. So basically when you actually use a Shak-Hartman wavefront sensor, you have a limitation of guide star magnitude. So if you go to dimmer stars, then you have to change the physical Shak-Hartman cell itself. So basically the pyramid wavefront sensor approach on the adaptive optics system will be able to adapt at different magnitude of stars, plus you don't have the disadvantage of undersampling features as it is in the Shak-Hartman wavefront sensor. So basically this gives an extreme level of correction, and 90% strail is really which I'll show you the results as well. The results are always in the lab, okay, so it's perfect, but we need to actually try it on the telescope too, but it's not going to differ like even a couple of % from what is observed. So basically using this system, now sky will no longer be a limit, but the telescope itself, the telescope will no longer be limit, but the only limitation will be the sky itself, so basically the field of view that you have. This is the physical Troya, which is built on the left-hand side. So here I'm going to explain a few specs. Basically the light enters from the telescope itself, so it goes to OAP. OAP0 is the mirror that will, off-axis parabola, that sends the light to the deformable mirror itself. So before the characterization, the deformable needs to be flat in order to do the measurements at the NUVU EMCCD camera. So basically we have all the equipment, monochromic, dichroic lenses, and then the pyramid wavefront sensor is just before the camera itself, where you see PYR. This is the pyramid wavefront sensor. It is built we actually purchased it from Canada, from the very same company as the TMT is using. The NUVU is also the MCCD purchased from Canada as well, and it is the very same equipment that, again, the TMT, the 30-meter telescope, is using at the nefarious adaptive optics system. Basically, the DM is from Alpao, from Grenoble, France, which has 468 actuators. So the good thing with the DM itself is that it both has a high stroke and high number of actuators. So this enables for a very good coverage of correction. And the tip tilt mirror, which is on the left-hand side, as you see, the TTM is when you have a 7 arc minutes of field of view, and if you want to pick a star, so basically you give the coordinates to the TTM, and it automatically starts picking the star and starts the tracking of the star, which you actually use as a guide star itself. So here you're going to see on the left-hand side on the bottom, and I have only shown not full 468 actuators. For each actuator means a mode, okay? So we start as defocus, coma, so on and so forth. Astigmatism, it goes on and on, as in terms of Zernike coefficients. So on the left-hand side, we have up to 66, which is given here, and on the right-hand side, I actually zoomed in for you to actually be able to actually see the correction level. So in terms of correction, the maximum deviation, maximum deformation is in the open loop mode is about 110 nanometers, where when you actually start the adaptive optics system, it goes down to 15 nanometers. So this actually shows the coverage and the correction level of the adaptive optics system. So on the top left side, you can see the static one. So what we have done on the left-hand side is that we gave an astigmatism in purpose to the system to actually correct it with the adaptive optics systems. And the second image from the left shows you the astigmatism fully corrected by the adaptive optics system. And on the top and top right side, the two images, the one on the left is under turbulence. So this is before the correction is applied, and on the right-hand side, the top far right, you can see that the EO system is fully functioning. So here, the way that we created the turbulence, the fact that the whole adaptive optics system is actually within the size of 90 by 90 centimeters, so it's a quite compact adaptive optics system with a lot of instruments, optical instruments in it. So we didn't have space to actually put a hot air turbulence generator system, but what we have done is we used acrylic on CDs in order to actually create the turbulence itself. So it was a quite high turbulence, but then you can see the improvement done by the AO system. You can see really the core on the top right side of the images. So what it actually relates in terms of physical output is that on the left-hand side, you can see the globular cluster. So it is, what is this? NGC 1249. This is simulation, by the way. So when the adaptive optics system is off, what you see on the second from the left on the bottom, that you don't pick anything. So when you turn the AO system, you can see that there are hundreds or not even thousands of stars that are within that cluster where you wouldn't be able to actually observe before the AO. And on the very top right, you can see the superposition of adaptive optics on and off. So basically, the image, the second image on the bottom on the left is without AO, and on the right, you can see that many stars were actually present on that cluster, which can only be picked up by the adaptive optics system itself. So this is the end of my presentation. Thank you for bearing with me, let's say. And if you have any questions, you can both direct your questions to Atasam or to Opam, so you will be answered equally. Yes.
We would like to thank Assistant Professor Onur Keskin for his speech, and I would like to invite Director of the Observatory Research and Application Center, Professor Tolga Güver, to present the certificate of Professor Onur Keskin. Professor Keskin, if you would like to. And now I would like to invite Assistant Professor Sinan Alish to chair this session. In this session, a total of 4 papers is going to present, one of which will be online. And now I would like to present the researchers who will present their papers in this session. I would like to invite Hasan Esenoğlu, Deniz Yazıcı, Faizan Aziz, and Itır Toksöz to present their papers. Now, I would like to give the floor to the session chair, Professor Sinan Alish.
Thank you. Good afternoon, everybody. I think this is going to be the shortest session of the symposium, and my job is, I hope, presumably it will be easy. Welcome. So, for every speaker, you have 15 minutes, and afterwards I will ask for the questions. I think this is much better this way. So let me give the floor to Mr. Esenoğlu about International Space Station dust measurement and meteorite analysis. So we are going to space. Okay.
Hello everybody, again. Okay, now I will we are present to our speech about asteroids. We will links from the ground-based laboratories and also the space. I wish to share some new ones for our studies. Title of the International Space Station, Dust Measurement and Meteorites. I will give you some important site because I have 60 page slides. It is not easy to say something more in detail and etc. So I have to run quickly. This study based on the laboratory results, but this also my colleagues is from different disciplines. So this studies depend on the interdisciplinary work. I wish to say about this. Yeah. If you look at some like this website in Turkish, you can just see in a new ideas from this like official about official website I can say, and you can see any some available information about the address. I wish to share also. For example, in our Turkey's boundaries hold about 26 meteorites in the time, so it is maybe interesting for you. I think so. I be interested in only one Çanakkale meteorite because it is very good result from the laboratories on this meteorite. Okay. If you look at this our meteorite in the Turkey's meteorite, you can see like this distribution. In Turkish, because if you look at the big one, the blue color, it means what does it mean? Ordinary, yeah, ordinary country is a very big present, and another one furrow should be very so much and another one, red color, should be also the mixed, you can say, like this one. Okay. Okay. It is very, this document, the first official report or paper about this Çanakkale meteorite. Sorry, in Dardanelles is a city, but is the spatial name Çanakkale. It is better to say in Turkish spatial or the official name. You can see some information about the address, local, and also some spatial parameters about the mass or others. Okay, also this site, the International Meteorite Society website, it is very important, this database. It means there are many official meteorites you can see and take some available data and the information also. You can see our Turkish meteorite you can from this site. Also, it is better to look at in the view this these maps. In Turkey, the Çanakkale, you can see easily also. Some another one, the address all Bayramiç. If you look at the detailed maps, you can also see it. Yeah. This artist stone viewing like this one, Çanakkale meteorite, the original one. There are three parts. Only this one, in İstanbul Üniversitesi Museum. You can see the cover and the shell. It means or burning shell or exterior or interior like this one, because it is very important this part to take some available information. Also another one, maybe it is interesting for you. In Turkey, the first time to published an asteroids paper, SCI. It is very interesting about this Çanakkale meteorite. I wish to share like this point because it's important. The first time, no in oral paper, no in the poster, no in the report. The official paper, the international SCI. Okay. Also, we gave an research project from TÜBİTAK and accept and complete this project. We installed many camera to see, to watch the original on the sky, these meteorites and some part of the Turkey by using some our universities. Okay. Our this paper, we have three aims about this study. The first one is important. We have good results, many results from any experimental tools from the laboratories anywhere and inside and outside also. We have good condition, but only depends on the ground-based results, no any from space, no any anything. Therefore, we wanted to compare these results with for example, the ISS results. It is main ideas for this study, this one. I wish to share. How many minutes? Because, okay, can I go? We use many laboratories from the universities in Turkey and also outside. For example, our university and Avcılar Cerrahpaşa. Some official also laboratories from the out of the university, and Canada also, and also NASA, US. I show you some samples, sorry, on information. Okay, I collect our results, all results from this official reports about this investigation on the meteorite, 60 items. I will show you also some samples for these results quickly. Please look at this on results. The first one, the basic result, the classification, you know, for everyone. And the second, we have some, which one is the elements and the, how can you say, I don't remember the name. Okay, I use many methods also. These meteorites. You can see also some spectra by using some experimental tools. From this inside of this meteorite and also outside from the shell. Okay, can quickly also. We have used many large electromagnetic spectrum because we need to extra elements also. Okay. The first beginning of this study, many years ago, maybe 10 or 12 years ago, is very remembered just now. And I used like these tools and the first list from the elements, these meteorites, about 68. Do you see? And it is very important. Some material. It is yeah. I can say. Also, it is important. Another one. You see the thin atomic under the electromagnetic microscope. So it is, if you see like this shape, like this chondrule, it should be very important to be an asteroid, meteorite, because it's very important sign. This the circle shape. Okay. Is there any extraterrestrial somethings about this asteroid also? We wanted to do some things. Also, I took from some soil from the Çanakkale and sent to the NASA to do some things about this. If you have any amino acid, for example. The result is the yes, okay, no negative result. It's very interesting. It's important also. You look at please some results from this. If you have any amino acid or carbon 13 isotope. Okay, all results in the past, not now. The recently new one, I also to do some extra in detail, more and more detail. Again, some experimental some things about this meteorite. We took some positive results and the published also recently, and look at please the paper. Okay, the first purpose is like this one. The second one, if you have some how can you say dirty, the ground-based dirty, for example. If you look at in the ground-based laboratories, it should be there is. But if you use the space laboratories, maybe it is can take the positive results. We prepared a proposal to the TÜBİTAK Uzay to do these like experimental sets. So we do some things. The box to take the space dust in the ISS. So we sent this experimental set to the TÜBİTAK Uzay about half an hour year ago. So no any positive results from the TÜBİTAK Uzay. No accepted. The last about 3 or 1 month ago. So if you have some the next generation, the next the time, if you have any say to take extra study from the in a government's and we will again send this this paper also. Okay, the second purpose is like this one, I can say. Purposes third one. Oh, sorry, no in English. Okay, no problem. Yeah, if you collect from any space dust from the ISS, inside the ISS, if there is some this dust, original dust, and we investigate together with the colleague, maybe it is also possible to detection of the microbiological organisms. We don't know, but in the future we will hope to see to do like this experimental. Okay, okay. The last one about this the living somethings finding this dust collection. Okay. For future, again, we will wish to continue this study for future. Again, we need to learn also the age of this meteorite, because we didn't do some things, and also this asteroid, where do you come from our the solar system? We want to learn to address of our near space. Maybe it is important. This thanks to us for this study from the government. I wish to share. Okay, thanks some official laboratories and our reference, and thanks from our universities. Thank you again.
Are there any questions or comments to Professor Esenoğlu? Okay, so I can actually, just to help a little bit clarifying, because apparently it was very heavy presentation. It was not easy to summarize in 15 minutes. But Professor Esanoğlu and the team he has involved has a long history in meteorite analysis in different type of meteorites. At first, Çanakkale meteorite, and they also applied to the Turkish Space Agency's astronaut mission for an experiment that brought to the ISS, International Space Station, but it was not accepted this time, but next time, hopefully.
Next time, we hope, next time. Okay. We will do something more and detail, inshallah.
Thank you for your studies. Thank you. Okay. So there's a question. Can you? Okay, doesn't matter.
Thank you very much for the presentation. It is a rare working area, in fact, I mean, in our country, but it is very common all over the world, and it works. It's just I learned that your proposal was not accepted.
Selected. Let's
selected,
yeah,
sorry.
Yeah.
But you can propose this also for other international space stations, for Chinese space stations as well, through UPSCO.
Yeah, but we prefer to our government the first time because very secret, please. And
I don't understand, but our government, our country is a member of UPSCO. So Turkish Space Agency can also facilitate this to UPSCO. I don't know, just an idea. So it is another opportunity for you, okay?
Yeah, and also you should think, you should consider that we don't know the next time when it will be. So I think you should take this, take the suggestions. Yeah.
Okay.
Yeah. This is valid for everybody. You have some other options.
Okay, so you can discuss later. Thank you for the suggestion proposal.
Thank you. Thank you.
Okay. So the next speaker is Deniz Yazıcı, and she's going to talk about some morphometric analysis of some selected Mars craters. It's very interesting. Yeah. So floor is yours. 15 minutes, please.
Okay. Deniz Yazıcı yazıyor. Şu. Şuradaki. Tamam. Okay. Hi everyone, you're welcome this section. My name is Deniz Yazıcı. I am PhD student at İstanbul Teknik University, Eurasia Earth Science Institute, Geodynamic Department. Together with Tolga Görüm and Cengiz Yıldırım, we are research morphometric analysis of landslides occurring within impact crater on Mars. Today I will show you small sample of the application that I will be in my PhD thesis. In this presentation we will compare the data set. At the same time I will show the analysis of the three crater we have chosen. I plan to start with introduction, crater morphology, formation of impact crater, study area, data sets, and finish the presentation with our results. Of course, as you know, the solar system consists of 8 planets. Our study area will be Mars because of a lot of satellite image, and it is similarity to Earth. In the late 1880, American geologist Gilbert fired small cannonballs at mud target to see what might happen. Gilbert was very interested in the origin of lunar crater and suggested that the Imperium feature on the moon was the result of an impact. Then in some experiments, the target simulated reduced gravity condition. This result from the facility enabled the derivation of the fundamental physics of the impacts and provided critical insight into the geological aspect of the impact crater. And I would like to show the few examples from around the world. This picture, meteor crater in Canada, this 100 kilometer diameter impact crater. This picture, aerial view of meteor crater in northern Arizona, the best preserved impact structure on Earth. This 1.2 kilometer diameter crater was formed about 15 billion years ago. This crater formed 200 million years ago. The moon is an excellent natural laboratory for studying various impact craters and their morphology. The crater morphology composed of the moon and other celestial bodies shows similar feature. What you see here, the translation of crater diameter size and impact crater morphology. Moon samples in this figure show well-preserved example of this crater morphology, different size and different name. Let's us now define some morphologic properties. For example, floor, ball-shaped or flat, below the surrounding ground level. Ejecta, the blanket of material surrounding the crater during the impact events. Raised rim, the rock is the ring-shaped pile on the rim of the crater after the impact events. Walls, structures that are characteristical step and have huge stairs called terraces. Same structure on the Earth. Rays, bright strikes starting from a crater and extending away for great distance. Finally, central uplift, mountain formed because of the huge increase and rapid decrease in pressure during the uplift impact events. A prime example of a young, well-preserved and documented simple impact crater on Earth, Bering Crater, USA. The most notable morphological difference between simple and complex impact crater is that complex impact crater contain patch distribution of crest and mount forming a central uplift. The 6 kilometer diameter crater in Jordan is a good example complex crater. You see a cross-section diagram showing the gradual development of the simple effect structure. It is roughly divided into 3 stages. Contact, excavation, modification stage, and in fact all of them are divided into sections within themselves. Actually, in fact, this event can be explained for hours, but it only takes a few seconds or a few minutes. Subsequent change reflect normal geological process of erosion and weathering. This photo on right, a simple lunar impact crater, ball-shaped. Second photo, a complex impact crater based on Venus. Finally, we chosen the Pankbohce, Barshpo, and Tomini crater. The reason we choose because they have the data we will use, and 3 craters located northern hemisphere. Our dataset are digital elevation model data produced by Hawaii Institute. Open source them data from Mars MOLA. Digital terrain map taken from the Mars Express satellites has a resolution of 75 meters. Finally, we use 5 centimeter resolution hill-shaped image. Actually, all of this data, DTM data. Imaging data of these orbiting satellites or drones capturing the ground in the raw form. The stereo image is raw data. We convert it with some remote sensing program or code. DTM generation generates numeric data. And finally, after we download data, we mapped it with ArcGIS and QGIS remote sensing program. We also measuring their depth and diameter. Here you can see the analysis we made with the MOLA data. We got spread within 3 crater profile within 3 crater. Likewise, analysis taken from Mars Express data, some low resolution data, be aware of, can measure depth. However, due to brightness, we use heat shades from CTX data inside of DTM. Here are DTM image produced in the high resolution and download Hawaii Institute data. We can see similar range when we compare the data sets. It is possible to use data numerical actually until we go to the Mars and collect samples return. The data we get will be the most reliable. Open source DTM can be used in our work. However, high resolution DTM a must for detailed geomorphological feature and geomorphological mapping. And now PhD students will continue download data and determining landslide within crater. Maybe after we estimated crater dating. I will plan 500 determined crater. Thank you so much for listening.
Okay, thank you for a very short time and using the time very properly. Are there any questions and comments? We have time for this. Yeah, you can. Sure, of course. Actually, you didn't, you mentioned, but it was not so clear that, so you get the data from the Mars Explorer satellite. So that is publicly available or you publicly available? Okay. No question, comment? Okay. So we started to investigate other planets from Turkey now. It's very exciting, actually. This is something recent. So the next speaker will be on talking on remote sensing. Faizan, can you hear us? Faizan Aziz, can you hear us? Duymaz mı? Sesimiz gidiyor değil mi? Peki. Okay. Faizan, can you hear?
I am Faizan Aziz.
Okay, so you have 15 minutes and I will warn you in the last 3 minutes, okay?
Okay.
So you can start, thank you.
Okay, hello, assalamu alaikum. Today my topic is spectral band registration and accuracy analysis for low feature satellite imagery based on a multi-scale correlation. Here we have a problem that sometimes we have such images which does not have extremely low features and which cannot be detected easily using image processing system. So we have built a methodology which could detect and correct the image registration. different band pixels are separated, especially in image plane. This means that the acquired image has a time shift. What does this means? That we acquired the image, and this has the problem that each band has an error due to time shift, and therefore they are not registered, and we do not have some accurate parameters receiving from the satellite. So using the model, it is very difficult to build this stuff to correct. Therefore, we use the image processing methodology. There are two types of methodology. Possibly number one is spectral registration image-based method, and the second is photometric-based method. Image-based method does not require any satellite position orientation information. Registration is achieved by conjugate point identification, transformation. Such technique work better in small scenes with no larger terrain. Images divided into image segments. We speed up our registration process by parallelization, using parallel processing to properly utilize the memory and processor resources. Image processing is divided into two parts. Number one is cursor registration, and the second part is fine registration. We first do cursor registration, and then the residues left, we find the fine registration to correct them at residues levels. And in this way, band is downsampled to the MS for cursor registration. We apply derivative to enhance image features. We use a FFT-based phase correlation technique to estimate the coordinate shifting. As there is no rotation, and as there is no rotation, so we just need to shift the image, not scaling, not rotating. This matrix is realized as a coarse registration method. Output will not save at this stage. Here is the process of cursor registration method. The image is first transformed into DFT, and then we find the power spectrum, and then finally apply the IDFT, and finally we find the peak values and at their positions. Fine registration. In fine registration, the big image is further segmented into small parts. Each part is once again applied FFT-based cross correlation. By applying these cross correlation, we have each segment points, and we use these segment points to correct the minor error, the residual error. To correct the residual error, we use the thin plate cubical spline method to model it and then correct it. There is an equation of thin plane cubical spline method, and here we find some error, and then we reduce its correction. Although the error is very minor, so we can not show directly on the image. It's about 1 pixel or maybe half of the pixel errors. Results. Although resampling is done twice for registration calculation, the resultant equation, the effective resampling is done only once, which does not degrade the multiple resampling method. In this way, we use the 2 times resampling, but we do not apply on image. We just do for the sake of calculation. After calculation and modeling, we all together apply on raw image directly. So in this way, only one time resampling is occur. For accuracy analysis, we do CE90 and RMSE method. And where we have the target to achieve is 0.5 pixel to achieve at CE90 and 0.35 pixel achieve at RMSE method. Now, here is a sample image. This is a whole strip of image of the satellite, and it is a portion which is corrected. And you can see that the feature is very light to be detected. And here is the answer. You will see that the green line is RMSE value and the red line is CE90 error. And these are the points where the pixels are detected, the peak values are detected, and their error along X and Y directions. This is for red and green and blue. Thank you.
Faizan, thank you for your presentation. As far as I understood that you developed an algorithm for the image analysis for the remote sensing data. Do you make an automated classification for those features, or you just produce the images with a new grid? Do you hear us?
Actually, I cannot hear properly because the sound quality is...
You cannot hear. Okay, we cannot hear either. Okay, doesn't matter. Okay, thank you very much for your contribution. So the next talk, actually the last talk of this session, is from Itır Toksöz, Space Activities, International Law and Foreign Policy and Access. Please. You have also 15 minutes. Yeah.
Geçtiniz az önce ama.
I will notify you in the last 2 minutes.
Okay.
Thank you.
Thank you very much for welcoming me to be a speaker today at this symposium. With your permission, I'll be wearing my mask because I'm undergoing some dental treatment and I don't want to look like I'm presenting in a Halloween party. Today I will be talking about space activities, international law, and foreign policy nexus. And of course, my paper seems to be a little bit of the alien of the panel, to be honest, but I think I will try to attract your attention towards it. Now, I'm an assistant professor of international relations at Doğuş University. I'm also the national coordinator for Turkey at the Moon Village Association, which is a Vienna-based transnational NGO working towards a lunar settlement. But the views and the expressions, the opinions that I will be expressing here today are my own and do not represent the views of the organizations that I represent. Basically, I would like to tell you first about my background a little bit. I'm an expert in international security. That's where my main field of research is. But for a long time, I did peace and conflict studies between 2012 and 2017. I was the president of the European Peace Research Association. For the longest time, I've been teaching elective courses on science, technology, and international relations. And I think for the last 10 years, space politics is my exclusive area of written research. I also do a lot of research on science fiction and politics. It looks like I don't know much about international law, but that's not true because I've been teaching international public law as well for the last 15 years at my university, and I participated in a lot of moot court international competitions in international humanitarian law. Now, my paper is going to investigate the connection between space activities, international law, and foreign policy, and my basic argument is that international law is made and enforced by state actors. Therefore, any issue relating to the international or national regulation of space activities is not only illegal, but also a political and therefore a foreign policy issue, and it should be discussed as such as well. So basically,
my aim in this paper is to acknowledge this connection and to discuss it within these parameters. While doing that, I will be taking a look at IR theory, the outer space regime, some challenges, and then maybe there will be questions about positions and instruments, and I will try to highlight these as well. Now, first of all, since yesterday during the symposium, many papers have addressed certain facts on the ground, and I will try to just highlight these and skip very fast. Now, during the Cold War, when the space activities first started, this was an exclusive domain of a limited number of state actors. There was the space race. Most of the goal of that space race was ideological and military, and it was geared towards gaining prestige and power. Now, when we reach to the immediate post-Cold War era, which means right in the 1990s and in the early 2000s, we can say, we saw emerging space actors. Well, they were there already, countries like Brazil, India, European Union as a space actor, maybe Japan, Canada, and so on, but we started to see them being more active in the area. So, instead of the space race, we started to talk about space cooperation. Scientific missions especially became more and more widespread during this period. And of course, through the space cooperation, there was more of a sharing of know-how, and space applications started to serve the end users, basically, during this time period. Today, to this picture, we can also add increasing number of non-state actors. Not only the commercial non-state actors, which as a technical term now we call as new space, but also intergovernmental actors such as APSCO and non-governmental actors such as the Moon Village Association that I represent, for example. Of course, today we talk more and more about space competition, not only among the states that are spacefaring, but also among the companies and also between states and the companies. So we see more and more missions that are going towards an economic mission with the idea of profit, benefit, but still also maybe national interest behind. Now, I would like to highlight the cooperative aspects of space politics because this is an important part of foreign policy. Now, in international relations, we generally say that states have two types of behavior. They either cooperate or they get into conflict. During the Cold War, we have seen how they got into conflict, and we also talk a lot about today's increasing rivalry between China and the United States and so on. But the cooperative sides of this political picture is also very important. Now, as early as the Cold War rivalry, actually, there was cooperation in outer space. That started with the Apollo-Soyuz program, and then within the blocks on each side, it followed on with the space programs that were geared towards the allies of the superpowers. For example, the Soviet Union had an Interkosmos program where they not only sent cosmonauts of the allied states such as Eastern Germany, Romania, Cuba, and so on, but also non-communist states such as France. Actually, the first Frenchman to go into outer space went through the Interkosmos program. The United States caught up with this trend through STS-9 mission, which was a space shuttle mission on. And that was in the early 1980s, basically. So they came on board later with that kind of cooperation. But during this time period, we also saw the emergence of the intergovernmental and the United Nations structures and the legal framework of how to go about conducting space activities. In the immediate post-Cold War, we see the emergence of International Space Station as the apex of cooperation, and also multiple bilateral and multilateral science missions, satellite launching, both in terms of manufacturing of the satellites and the launching of the satellites became a business. All of this was happening, by the way, during a time period where the countries were not really so sure about what to do about China, and China, unfortunately, got excluded from this cooperative picture, which kind of worked for the Chinese benefit because that pushed them towards becoming self-sufficient on their own. Today, we have a complex picture. We have state-to-state cooperation, state-business cooperation, as in the case of NASA, SpaceX. We have state, non-state cooperation. For example, in Israel, the first lunar mission of Israel was done by a non-governmental organization called SpaceIL that launched the Bereshit 1 mission. There are intergovernmental organizations, business-to-business cooperation, and you name it. Now, some observations about today's picture after this, let's say, short historical overview. Almost all new state actors trying to go into outer space need cooperation to go into outer space. They do not have the technology, they do not have the know-how or the means, or they are developing them as we speak, and the way to do it is to enter into cooperative arrangements with the already established actors. But the established state powers, they also go into space cooperations even if they do not technically need it. They do this in order to cut the costs and share the burden, and of course share the globalized technologies. Now, who an actor cooperates with depends on their foreign policy. And here is the more political picture coming in. For example, United States, it is cooperating mostly with its allies. It has cooperated with Russia in the ISS program, but now because of the Ukraine crisis, this seems to be questioned. But it did not cooperate with China due to the ITAR regulations in the United States. China generally cooperates with regional states, but it does also cooperate with European actors in space projects as well. Europe pretty much cooperates with everybody, and Turkey, as we understand, tries also to follow on the path of diversifying the cooperative aspects and is not only trying to engage state actors, but also the non-state actors. So, a state's foreign policy has a high significance for the success of a state's space activities through which they can align and whose technology and know-how they can share and learn from. On the flip side of the coin, space activities and capabilities, they also play an important part in shaping a state's foreign policy. For example, through Earth observation or remote sensing, countries are able to gather information about friends and foes. They can collect and share data about global, regional, and environmental problems, and they can learn how to better deal with man-made or natural disasters. Again, through the usage of communications technologies, they can speed up economic transactions, trade relations, and they can also exert soft powers in their neighborhood and even in their extended neighborhoods. This was something that Turkey has done very successfully through the TürkSat network by the broadcast of several different programs. And of course, the military uses of space-based assets, they facilitate, support, and help shape national security policies. Now, coming from my own field of international relations, we can say that there are several different theories of IR, but I'm not going to go into the details of this. The two major and very, very classical theories of international relations are realism and liberalism. Basically, these two theories agree on one point. They say that the world is in a state of anarchy. Anarchy here is not an unregulated area, but anarchy in international relations means lack of a world government, lack of a central authority to make and enforce rules. And therefore, while the realist theory of international relations says that, that makes states power hungry, where they engage in power struggles and they pursue always their national interests in order to overcome the side effects of this anarchy. They engage in balance of power politics and in alliances. On the flip side of the coin again, liberalism says that no, we do not have to engage in this power struggle, but we can overcome the unintended or the unwanted effects of anarchy through cooperation in international organizations, in international law, economic cooperation, and the use of soft power. Now, in space, well, while this picture seems to hold to a certain degree, we also see deviations from this picture. The explanations, therefore, may be less simplistic. For example, although they were old rivals of the Cold War, the United States and the Russian Federation, at the immediate intermat of the Cold War, they were able to find one another easily cooperating. Then, United States and China, they traded on Earth, but they did not cooperate in space. So we can say that states are highly selective when it comes to whom they cooperate with in their space activities. The current challenges, some of which were addressed by the speakers yesterday in our panels, are vertical proliferation, which means more space objects, horizontal proliferation, which means more space actors, both state and non-state, which increases orbital traffic, and the space debris, of course. Now, there is the issue of what I will call the gold rush of the new space, which we have identified as the business entities, where we see a highly, let's say, or a high percentage of the end user technology and the multiplication of downstream services, the upcoming challenges of space mining and space tourism and space manufacturing, in-orbit servicing, even going towards the issue of colonization. We see the expansion of space sector. Now, yesterday, after I left the panels here, I went home, and at 8 o'clock, in the United States, by an organization called On Orbit, there was a panel on the value of space medicine. And it was the most interesting panel, where they have highlighted the use of microgravity environment in order to grow human tissues to be used as the testing grounds for the pharmaceutical industry. Okay? So we see space sector going into places where it wasn't before. Yesterday, Associate Professor Mesut Gökten from TÜBİTAK Uzay has shown us the pictures of IMECE, where he said that there was a special box that was built for IMECE. And even the producer of that box is now a part of the space sector. So it is going into areas where it wasn't before. Space militarization and space securitization is not only about the security of state, security of downstream services, security of space assets, but the security of access to space as well. And of course, as well as the existing outer space regime, we see the transparency and confidence building measures coming up, several code of conduct proposals by Russia, European Union, China, and so on. The international law seems not to be adequate here, but also there is more and more national law. Now, in almost all of the international conferences I go to and I attend to, international law seems to be the highlight. But the states are also challenged in creating their national regulatory frameworks. And that happens within political debates internally in these states as well. I'm not going to go into the details of this. This is the current outer space regimes, but we can say that there are no new treaties, hard law treaties, binding treaties for the last 50 years, and all institutionalization in terms of the bodies created and the law that has been put forward in the international area are fruits of the Cold War years. So, the current regime in international law seems to be outdated and irresponsive to current challenges, but it is actually basic enough to keep on going with the space activities because it has certain advantages like pushing forward the principles of peaceful use, non-weaponization, and common heritage of mankind, and the existing outer space regime is widely accepted and internalized. But it is probably not sustainable for the future. There is a need for new legal and regulatory frameworks to be done by state actors within political settings with pressure and input from several non-state actors on subnational, international, and transnational or global levels of analysis. So all of these different stakeholders in outer space, they each have their own agenda. While yesterday in the panels, in other international conferences, we may be talking about we should, we must. It is not we as scientists or lawyers or engineers or academics who are generally acting as advisors to the policymakers if they care to listen to us. But it is the policymakers that we need to convince of the necessity of these things. And this thinking does not happen in a legal or a technical framework. It also happens in a political framework, which we need to pay attention to. So basically, legal, technical, scientific arguments, unfortunately, do not always suffice to convince political actors. And that is why I am here to present you to this dilemma. Now, I just wanted to include a couple of cartoons to leave by on the uses of international law and the outer space. This is a courtroom, and basically the attorney is saying, and now I'd like to introduce my main witness, who saw it all from outer space. Another one is the moon for sale, and how do we deal with this? And a third one is, while there may be peace and cooperation in space, good luck to Earth. We're still fighting with one another, and in order to maintain our own affairs, maybe we have to merge the two spheres of the surface and the outer space together. There is to the stars through the hardships, as always. Per aspera ad astra. Thank you very much.
So we thank you for Itırtoxos for her nice talk. Are there any questions, comments on this topic? This is a very hot topic, actually. Yeah, my comment will be on that, as we also listened in this morning, Professor Benvenuti, is that, I mean, as astronomers, we are suffering a lot in these days. Okay, everyone is agree on the need for an update in the space law, space regulations. But as long as there's an economical benefit, especially a huge economical benefit from space, I think this will right, somehow it will be ignored for the sake of the commercial product. I mean, companies or states. I don't know. We will see. It's very typical. It's very similar with the environmental actions and climate crisis. The same, and we will have a space crisis in the near future. It's unavoidable, actually. Yeah. Anyway, okay. No comments, no questions. So we thank all the speakers of this session. I am closing this session, I think, on time. Do we have a break? Yeah, okay, we have a 10 minutes break, and after that, we will convene for the last session. Thank you.
And thank you for the presentations. And I would like to invite Assistant Professor Sinan Alish, who is the chair of this session and the member of the organizing committee, to present the certificates to the presenters. Thank you. hocam bilmiyorum ama. So this is the end of the fourth session. We have a very brief break, 10 minutes, and then we are going to gather for fifth session. Thank you. Distinguished deans and dear guests, this is the fifth and unfortunately the last session of our symposium. For this session, I would like to invite the Dean of Faculty of Science, Associate Professor Volkan Hacıoğlu, to chair the fifth session of the symposium. In this session, a total of 5 papers, which 3 of them will be online, are going to be presented. And now I would like to also call the names of the presenters, which are Welki Arbaiza Abanto, Aşkın İnci Sökmen Alaca, Arzu Aktaş, Elif Yağmur, and Sandeep Abhat to present their papers. Now I would like to give the floor to the session chair, Associate Professor Volkan Hacıoğlu. Thank you.
Okay. Thank you for attending the final session of this symposium. And the first presentation will be made by Andre Welki Arbazia Bento, and the affiliated institution will be Space Agency of Peru, and he will be attending from the Peru country. And the title of the paper, Development of Space Applications with the Peruvian Satellite System. This presentation will be online, and now we need to connect with this.
Hello, can you hear me?
Yes, we hear you,
am.
Mr. Andre.
Okay, yeah.
Now you got 15 minutes to present your paper, and
yeah,
you may commence if you are ready.
Yeah, I am ready.
Okay, we are watching that.
Well, good afternoon. Who talked you is the Captain Andrea Arbaiz Abanto, Chief of the Information Technology Office. My few words, I am so appreciative for the opportunity like speaker in representation by CONIDA. Royal for everyone. In this opportunity, I would like to talk how Peruvian satellite have allowed to get some achievement and beneficial for the Peru. And little by little, these outcomes have helped to different organizations until today. Well, this is a short summary. Well, we are going to have 4 points where we will start with the Peruvian Spatial System, PSS, and then about the interinstitutional project jointly with other organizations after the direction of the geometric and spatial application, which one principal direction that using satellite information to make product with value added. And the last above of Permanent Alert Service. Peruvian Satellite System, PSS. Due to Peruvian satellite, Peru belongs a satellite constellation and also use other satellites to get images of different resolution. You can see the radar satellite is SACOM from Argentina, and the other optical satellites. In the image show different types of satellites. So, about the Peruvian satellite have next future. Well, I only mentioned the principal. Spectral resolution, the Perusat have 5 bands: RGB, panchromatic, and near infrared. So spatial resolution is symmetry because the scope is 70 centimeters, in which that is less of 1 meter. About the DIM, model elevation digital, the satellite permits to capture in 2 and 3 dimension image. Well, you can see 2 areas about what direction participate in this in this producing this image. Noise provide us satellite information. Is the center where is the antenna that gets in satellite information. Then this information is used by DIAGP to make products with value added. About international projects. In this slide, you can see CONIDA work jointly with many organizations, as public as private, and which one through satellite information have could develop projects to prevent risks, warning, and fraud. The Peru have nowadays one of these is DESI, what is a public organization subscribing by Defense Minister. CONIDA has to the GDR, or now like management of natural disaster, with university have worked projects such as water bodies, where look into to be behavior of the water and the different parts of Peru. Well, this is example, or this is a result of that by the principal direction. In this slide, you can see this flood report have been produced with Perusat and CONSAT satellite information. The blue point displays some flood, and red point display affect nervous zones. This is other example. This flood report has been produced with Sentinel satellite information. It is saying that is the before example that blue points display some flood and red point display affect nervous zones. Well, about that landslide, in this picture you can see the before and the after of disaster, how affecting around area. Then, employing Perusat satellite information, the CONIDA participate actively in the important project to identify coca cultivation. This is a project started in the 2021 and finished in this year. Permanent alert services on SAT. This slide shows the methodology success the requesting of the satellite until to the outcome in the value added. This process is engaging COEN, what is the natural center of emerging operation, and CONIDA. Their principal aim is supporting on the information to prevent unreasoned threats. Thank you so much. That's all.
Thank you, Mr. Andre, for your technical and rather visual presentation. And let me ask to the audiences if they have any questions or comments on that presentation. please. And no question, okay. And thank you, Mr. Andreden, for your presentation. Now we move on to the second presentation by İnci Sökmen Alaca from Istanbul University, Turkey. And the title of the presentation will be New Space Power, China's Target and its Effect on International Politics. And the area, space, economy, this presentation will be in person. You have 15 minutes.
All right. Okay. Thank you, first of all, for all organizer committee as accepting me for that conference. I'm looking at that topics from the international relations and security studies, and currently, as you know, there are huge confrontations between China and US, especially in the global politics. And now the China rising economically, militarily and politically are critically important for the global politics and also Asian security studies. And now the China is so successful. Actually, when look at the Chinese strategies in the future, they are focusing on the emerging on new technologies like quantum technology, quantum teleportations, and new types of the rockets and space stations. Therefore, currently the China has been regarded third elite groups of space power. That means after the Soviet Union or Russia and currently US, and the third one is China. And now the fourth one is India, is following the Chinese, the same path for the being great powers or one of the great powers in Asia or in global politics or in space area. Therefore, China is a good model for the being, how you can achieve a good space power in the global politics. In my presentation, actually, I focus on this success, how affect the current balance of the power in global politics. Especially China has so much focus on the asymmetrical power projections against the US military, because currently the containment strategy of the US is surrounded by the East Asia and also in South Asia and the other regions. Therefore, China has already felt insecure in the global politics, and to protect itself, the best way to achieve asymmetrical power projection, especially in the space. Therefore, currently China tested many new types of the militarization. For example, my colleagues mentioned international law, the militarizations of the space, but currently new space weapons are different. Now we are not talking about the nuclear missiles. We are talking about the electromagnetic weapons or laser beam weapons, or currently the US Thor project. It's the completely different new weapons. And they are also using the satellite, turning to the weapons. Therefore, in our outer space, especially surrounded by the world, our Earth, with full of the military satellites. Some of them are weapons, but we are not aware about that situations. This is secretly intelligence operations. They continue from the outer space directly to the Earth. And now the China, especially, first of all, military and defense. What is the purpose of China in the space? First one, military and defense. Second one, national prestige. And third one, scientific exploration. And last one, deterrence, especially against the US and US military operations, secret operations or direct operations towards the China. And what else? Chinese space program especially includes the deep space exploration, Moon, Mars, and beyond Mars and Jupiter. And also a manned space station has already improving this space station, but next years or 2 years later, we will see their space station in surrounding of the Earth. And also the last cutting edge advancements in technology, new materials, robotics, and artificial intelligence. According to the May 2025 strategy of China, China would like to be first-ranked country in quantum technology, in artificial intelligence technology and robotic technology, and also genetic and biological technology. Therefore, all these technologies are critically important to become a leader in the space. Because lunar projects in 2024, many countries have already built some plans to build their lunar villages. Just not villages, these are the scientific laboratories. And here China would be first. And then, of course, the space mining and using the helium-3 minerals from the lunar surface just to produce nuclear energy from the lunar towards the Earth. And also again, they are so critically secretly operation, because all the time the US policy makers say that we are not so safe about the Chinese currently space activities because they are keep secretly something. And all the time, the superiority in Earth, in space. This is the main topics between the China and US confrontations in the currently in global politics. And what else? China is currently the similar path as the US and Russia, and generally not moving appreciably faster. And also US faces important questions about the future of its relationship with China in space. For example, some materials in the media, China all the time highlighting that we are peaceful missions in space. But again, US are not so much believe what they say about the space. And also, again, everything began in 2003 with first man in space. But up to now, they have achieved many things. For example, to competition with SpaceX and constellations of the many constellations, they also sent many satellites at the same time, like India. Therefore, currently, after the rising of the China being a space power in the world, the fourth country is India, follow very closely the China, and also Japan, and also South Korea. And of course, currently they help the Turkey in the EBSCO organization about sharing their technological advancements and knowledge with the members of the EBSCO in China. And also, as you see, the Chinese space station currently, Tiangong is already planned, and some parts have already developed, but not currently deployed to the space, but just they are waiting due to the COVID-19 diseases. This project has postponed for a while, but now, from now on, they are working on very fastly about that project. And also, again, they have also producing some materials, documentaries, like space white paper, and also in military side, we will see new space war doctrines. They call this one light war. What does it mean, light war? That means the weapons are based on the laser beam or electromagnetic spectrum. China has already achieved to be landed on the dark side of the moon, and there they made some secret testing of the electromagnetic spectrum. Therefore, in the next years, the weapons of the space would be completely different from the nuclear warheads. And maybe Thor projects, so similar like light beam weapons, they will be used against US or the other rivalry countries in the Asia. Therefore, currently the Chinese stations in the space have already completely changed the power balance in Asia, in global politics against the US. And also, this is they call the new space race between the China and US. And in the new space race, the first target is moon or lunar. And we know that currently the Biden administration postponed the lunar project Artemis. Maybe next year they will try to send some equipments to the lunar, but still they are facing difficulties. As you know, the SpaceX last launch failed. Therefore, it's not easy to achieve some things in the space stations. Of course, the United States is completely different path because has already built Space Force, and also in the NATO documents we will discuss a new strategic confrontations place between the NATO members and the other non-NATO members. And also, as you see here in the Chinese plan to exploit Earth-Moon space for industrial development, and also lunar explorations, and also again using 100 tons of helium-3 could supply the world's electrical needs for 1 year. And also again the Peleos secret weapons testing has already done in the satellites and also the other places. And also they very successfully tested ASAT, anti-satellite weapons from Earth towards to this space. And also, again, you see in the media, there are some mysteries, suspicions about the Chinese achievements or Chinese testing. Even in the space station, the Americans talk that they will be secretly testing of the weapons or biological weapons or other things. Therefore, this is actually leads to so much untrustful relationship in the international system. Of course, US has not yet alone, together with ESA and also together with India, China, India, North Korea, India, South Korea, and Japan. They pushing these Asian countries to rebalancing of the China in outer space. Therefore, to sum up to all the things from the perspective of international relations and security studies, space would be very important place strategically to changing the status of the great power in the future. And also China completely a good leader for the hegemony of the system because they already began to change the rules of the international economy. And plus, in science exploration, they are so successful than the US. Of course, it is not easy to accept all the achievements, especially by the US forces and Pentagon and also White House. Therefore, all the time they are sending so dark side propaganda on the social media about these secret and mystery actions of China. But China say that, I am also open to everyone. Please look at me and please follow my papers and follow my scientific exploration. Everything is there. But actually, to my opinion, especially quantum teleportations, the quantum teleportation is directly taking the knowledge from the satellites secretly. It's so easy. Therefore, currently, in the outer space, China can collect many important commercial and military data through the quantum teleportations. They test it, they achieve. Therefore, of course, these events show that sometimes we have to not so much trust to the China. Maybe it would be next time we will face different aspects of to them. All the time, I agree about the Americans in that issue. And to sum up to my presentation, that means if you want to be like China is a good model, and also the Turkey currently focus on the being one of the space power groups, but it takes the time because first of all we have to send manned space flight to the outer space, but it takes the time. Currently, we are the training stations. We have already choose our astronauts, but next years we will see maybe new our crafts and spacecraft, and also cooperations with other countries would be on loan. That's all. Right.
Okay, thanks to Mrs. İnci Sökmen Alaca for her insightful presentation. Now we move on to the other presentation. This will be again online presentation. Elif Yağmur from Atatürk University, and the title of the paper is Digital Monitoring of Project Management Processes in Space Sciences and a Systematic Approach Based on the Prediction Model.
Can you hear me now?
Yes, we hear you, said Elif.
Okay, can I share my screen?
Yes, please. And you can use your time, 15 minutes.
Okay. I think you can see my screen.
Yes, we can see your presentation now.
Okay. Good afternoon, dear participants. Firstly, I'd like to introduce myself. I am Elif Yağmur. I'm a PhD student at Atatürk University, Department of Management Information Systems. At the same time, I work as a researcher student of a TÜBİTAK project conducted within Atasan. And today I will talk about our study that we call Digital Monitoring of Project Management Processes in Space Sciences and a Systematic Approach Based on the Prediction Model. And our goal is here to explain how the processes is carried out in the projects conducted within Atasan and how we will continue with the system in the future. And we believe that this system, this systematic approach, will provide more efficient project management processes in space sciences projects. Firstly, I'd like to explain our purpose in this study. These are the core knowledge areas, as you can see, such as integration management, scope, time, cost, and others, and which these are very important and indispensable areas for each of our projects. In order for our projects to be carried out successfully, we have to follow them. We have to follow all these areas in the best way. And we aim to digitally monitor these areas or projects carried out in Atasan and to present a systematic approach based on the prediction model. And also, we want to add some smart capabilities to this by creating digital form of real-time project management. And it's our aim in this direction directs us to create a digital twin, actually, and with the smart capabilities to create a smart digital twin. And our results, what do we expect as a result of our study? Firstly, data analysis, of course. We want to perform data analysis based on the predictive model. And we want to create a system which can summarize project inputs and outputs. And being able to have this, being able to have inputs and outputs will be a very important step for the projects that are currently underway and the projects that we will consider in the future. And with all these features, when this system properly configured and turned into an API, a plugin will be developed. And this plugin will provide support to the decision maker or makers. And the other results we expect, more effective PM processes, of course, our main aim actually. And the creation of this digital twin project will also enable more effective analysis of space sciences data. And also this system will contribute to the growth of the space sciences ecosystem. And now I want to show you a flow chart. This flow chart, these steps will take to create the system will be like this basically. We'll apply all the steps in detail, starting from choosing a framework and will have completed the project process by reaching the effective reporting step, and these reports will provide support to the decision makers. And I briefly explain all the steps. Firstly, choosing a framework. In this stage, we have some frameworks like PM Guide and the Prince2, but also we follow and research some guides and the methods which can be a framework about PM process in literature. But for now, we now take as the basis these two, Prince2 and the PM Guide. And the second step, we need a pilot project for testing. But before that, before testing, we know that the outputs of our projects don't give us just one thing. I mean, project outputs are very diverse. For example, scientific observation, software, R&D, or infrastructure or technology. We can produce different outputs like this. And because of that, when we choose a project, we have to care about these outputs issue. So the pilot project should contain all these outputs, all these characteristics. And we have some alternatives for it. For example, choosing a completed project, or choosing an ongoing project, or choosing a virtual project. And this virtual project means we want to do in future via DAC or other telescopes we want. And also in this stage, we can try all of them. We can try all these options instead of just picking one. And then we need a PM software for analysis and job tracking. In addition to the software we currently use, for example, Confluence, we usually use it for documentation. PM software will be preferred considering the project requirements. We have some requirements. So what these requirements be? For example, using Confluence, as I said, will be sufficient if the project is generally document-based. Or in projects that will create product outputs, we'll have to apply all the ALM and the PLM stage, and we have to select the appropriate software for it. And this criteria will be important in software selection. At the same time, job tracking, it's another important issue for us for a current project and the future project. And in this case, we'll use a software like Jira for job tracking. And also we can continue with more than one software. I mean, we can use Confluence, and also we can use a PLM software or another software also. There is no limitation here. And we can have multiple options in this stage. For example, we can use Confluence and PLMs or the other softwares. And in this case, we'll use one of multi-criteria decision-making methods to choose the most effective, the most suitable software. For example, we can use AHB, analytic hierarchy process, or other multi-criteria decision-making methods. We can use it. And the other crucial step for us, determine the performance indicators. First of all, we want this system to be smart, and we have some basic requirements. For example, if the specified limits are exceeded, it should be able to give us a warning. And this system should be able to create forecasting for the future project. And also this system should be able to offer suggestions. But how? Which features can achieve all these requirements? To achieve this, we'll determine by interviewing with the project experts using some research methods and conducted in-depth interviews with them. And in the end, we'll have reached the indicators we want. And relation this, I want to show you a triangle. This is the PM triangle. It includes three basic values: scope, cost, and time. And we take it as the basis for an effective PM process. And we evaluate all the components and the features of our projects, including inputs and outputs or requirements. And all projects should contain these three basic values. And the second one, as you can see, we created it thanks to the PM triangle. And we want to evaluate our projects according with this second image. And these every points here are a project. And all of these start different time or use different codes or have this different scopes. And our aim to follow them in digitally, we want this system with the smart capabilities can give some results, some forecasting for the future projects. For example, for a new project, we have to know some information. I mean, we need to be able to say how many employees or how many costs or time we will need in future. And to know that, we'll back and we'll check the data which created by these systems. And this system will give us these informations. And the other step, choosing an algorithm, we need an intelligent algorithm to use. And by making this choice, some comparison studies can also be carried out with the objectives. For example, performance comparisons between the algorithms. And we'll choose an algorithm to data analysis. And then testing step. I want to show you a flowchart again. This is the last one, testing step. In this stage, if the expected results are met with this test, the results will be reported and these reports will provide to the decision makers. But if the expectations are not met, in this case, the selected algorithm will be checked in this stage and repeated tests will be performed. And then if the expected values are still not reached after the control, we'll control again this stage, determination of performance indicators, parameters. We control it, we check it, and check the algorithm again and testing again. And after that, tests will be conducted and reported in a framework, and these reports will provide to decision makers. This system will work like that basically. With this system, we aim to monitor the comprehensive research activities and the project management processes within ATASAM in digital environment. And also, as you can see from the steps we want to implement, this system will create various outputs, just like our projects. For example, we'll be able to access financial or administrative data, or we'll have information that can show us deficiencies or requirements at the software part, at this stage, choosing a PM software. And all these outputs will make this system smarter and more effective. And lastly, as I said at the beginning, we believe that with this system will also enable more effective analysis of space sciences data, and it will contribute to the growth of the space sciences ecosystem. This is the end of my presentation. This is the system we want to do it in future. Thank you for your listening. If you have any question about that, I can hear you.
Thank you, Elif Yağmur. And let me ask the audience if they have any questions or comments on your presentation. I think there is no question or comment. Thank you, Elif Yağmur, for your presentation again.
Thank you for your listening.
And our session continues with another presentation, Mrs. Arzu Aktaş, and from Yalova University. And title of the paper is The Taxation of Space Activities and its Relationship with Space Accounting. The area is, again, the space economy, and you have 15 minutes for your presentation, and you can start if you are ready now. You can start, of course.
Yes, I am all ready now. Good afternoon. Hi, everyone. I am Arzu Aktaş. I am a certified public accountant. We presented a paper before this place on space accounting again, and which was hosted in Istanbul University. And first of all, it is with my friends and Murat Azaltun, professor, and Ayşe Atasoy and Ismail Tekbaş together prepared this study. And before we presented a paper in the world, first in the world, about space accounting in NIDE 2019. After that, we presented we had the first International Space Accounting Workshop on December 7th, 2022, which hosted by Sakarya University, Finance and Accounting Association, and Sakarya Chamber of Certified Public Accountants. And this is most important for us because of we achieved important results with valuable participants. And now I want to thank you. I would like to thank you again your invitation and accepting our topic. The taxation of space activities and its relationship of space accounting. Our topic is very important because of Why? Because of the global space industry is a fast-growing sector of the world high-tech market. The global space economy, which has created a value of $447 billion in 2022, is growing day by day. With space mining and space tourism, this figure is expected to increase substantially in the coming years. According to the general estimation of economists interested in the space market, the size of the space economy is expected to reach $1 trillion in 2013. Yes, some of, I think we can't see the titles. How can you see there? It's important for me. Okay, space economy, global economy. Innovation activities are culminating in the development of new space systems and the facilitation of cost-effective launch of rockets into space. It is anticipated that the decrease in rocket cost will pave the way for an exponential upsurge in economic activities in space. The current situation, thank you. It's so easy now. The current situation, in conjunction with the advent of the new space economy, has brought to the forefront a multitude of specialized issues such as ownership, right to use, and profit-oriented utilization of space, as set forth in the Moon Agreement of 1979, thereby necessitating the imposition of taxes. The taxation of space activities is one of the most important uncertainty. The employment and taxation of satellites represent one of the most salient challenges confronted by tax authorities. Instances where a satellite belonging to one country orbits around another country and provides services to a third country give rise to a host of taxation-related predicaments. Because of all these developments, it can be asserted that no comprehensive tax system has been developed, yet pertinent to space activities, and numerous gaps persist in relation to the taxation of space. This study aims to explain the uncertainties that will arise in the context of taxation of space activities and discuss the necessity, significance, and interrelationship of, and I can't see it there. Why? I can't see all of them, all the part. Continue, okay. Taxation space. Yes. Okay, thank you. I'm sorry. Yes, the Outer Space Treaty, which entered into force in 1967, stipulates that space and celestial bodies utilization should be carried out for the benefit and interests of all countries and prohibits national appropriation of outer space via any means, including claims of sovereignty or occupation. This regulation offers no guidance on whether precious metals can be mined in space. A comparable circumstance arises in maritime law, where the nation of the high seas has been widely recognized as a domain where ships can move without restraint beyond the jurisdiction of any state. This rule has also been included in space law. The non-appropriation rule restricts those who wish to carry out commercial activities in space. On the other hand, the inability of states to claim sovereignty in space could lead to violations of the non-appropriation rule when it comes to the taxation of activities in space. In other words, concepts such as ownership, personality, and property form the basic principles of taxation. Therefore, it is necessary to establish a conceptual framework that includes tax liability for profits arising from space activities, determination of the tax base, identification of the tax collector and its authority, clarification of residency, and establishment status in order to resolve this paradoxical issue. For all these reasons, it is an important issue to decide how to taxation space activities. Space tourism is another topic that is often discussed in connection with the taxation of space activities. Shortly after Jeff Bezos completed his first space flight, Earl Munar, a member of the U.S. Congress House of Representatives, announced that he was working on a new tax plan aimed at space tourism. Munar suggested that the Space Tax Act should include a tax per passenger on the price of a commercial space flight, similar to commercial aviation. One alternative model for taxing space activities could entail the development of a voluntary tax system predicated on the engagement of participating countries. Countries that opt to participate in this scheme would be more inclined to invest in space technology, with the expectation of reaping the benefits. The system takes into account the interests of both countries engaging in space activities and those that join the system. However, it could also give rise to fairness issues as a voluntary tax system for space activities. This proposed system may provide advantages for countries with low investment in space activities compared to others. To avoid these problems, there will be a need for a universal organization to manage the process of taxing space activities. This organization could define tax rules based on different categories of space activities, for example, space tourism tax, asteroid mining tax, accommodation tax, and etc. Another question that arises for taxpayers regarding the taxation of space activities is, what is an appropriate tax year? While a Mars year is 686 Earth days, a day on Uranus is 34 Earth years. This situation leads to uncertainties in terms of taxation periods. Another uncertainty is the issue of tax reporting and collection in space. Although these developments will lead to a relationship between the taxation of space activities and space accounting. The relationship between the taxation of space activities and space accounting. The computation and declaration of taxes payable to the government are typically accomplished through accounting. Although taxation and accounting are distinct fields of study, they share a symbiotic relationship. All financial transactions that are recorded in the accounting process are leveraged for tax computation purposes. Accounting is extremely important in accurately calculating the tax base. When it comes to space, new accounting standards can be added to the existing accounting standards in the world, and new cost methods may be needed due to production in zero gravity. Future economic activities in space may necessitate the development of novel measurement techniques that are currently unknown and perhaps even unforeseeable. In such a scenario, proficiency in space accounting is envisaged as being indispensable to address the challenges that arise in connection with the taxation of space. A new accounting system is needed. It can be argued that due to the borderless nature of space, economic activities in this domain will be notably diverse, because space is abstract and infinite. In other words, space encompasses everything beyond our planet. Currently, accounting standards are primarily focused on preparing and reporting financial statements related to economic activities on Earth. Consequently, the accounting principles, standards, and practices in use today have been developed solely to fulfill the information requirements of third parties regarding commercial activities occurring within the Earth's boundaries. Hence, to accurately calculate taxes beyond Earth's boundaries, high-quality financial reporting standards are needed, established by accounting systems that consider the external conditions of space and provide prompt, reliable, impartial, accurate, and truthful information. These requirements can be categorized as a separate topic under the notion of space accounting, which is a novel accounting field. At this point, we can find answers to questions such as the determination of how tax legislation related to space activities will be established, how tax expenses will be computed, how the tax base will be established in terms of profit, income, cost, and tax value calculation, who will collect the tax, who will bear the responsibility and accountability, and whether practices such as double taxation prevention agreements will be implemented in space accounting. Conclusion. The taxation of space activities is a relatively new and not yet fully developed topic. Many of the space activities that will be subject to taxation need to be realized, become widespread, and create economic value before the parties that will benefit from this value can be identified. Only then space activities can be evaluated as a taxable activity. Currently, there is a lack of specific tax legislation for the taxation of space activities. However, it is important to note that while the concept of space refers to any area beyond the Earth, it also presents opportunities for the utilization of resources on our planet. Hence, it may be necessary to develop a taxation mechanism that considers the impact of space activities on the use of Earth's resources. In order to manage the taxation system in space correctly, it is another problem in the literature that the key parameters used in determining the tax base, such as measurement, evaluation, and cost matters, as well as the problems of ownership, right to use and use of the orbits or materials, and standards that accurately. Our aim is to emphasize the importance of accounting in commercial space created in the space. Economy development around the new space concept based on the satellite industry. As you know, we can measure the result of all economic or commercial activities with accounting, because accounting is an information and reporting system. The value and income cannot be calculated without accounting, and the tax to be derived from it cannot be calculated. Therefore, if there is an income and profit somewhere, there will definitely be tax and accounting. Perhaps the question is, can taxes be collected without an accountant or accountancy? Should have asked. There is a strong and deep-rooted relationship between the concepts of accounting and tax. Just as accounting cannot be done without the guidance of tax laws, it is not possible to reach a tax base without accounting. If accounting were driving a car, tax legislation would probably have been traffic signs. The smallest accounting slips record, like the drops forming the ocean, provides the financial statements of all companies, then the countries, and finally the world's gross national products figures. At this point, we wanted to draw attention to the taxation of space activities as a title under the concept of space accountancy, and accounting standards is insufficient. To properly accounting for, report, and calculate the tax base of space activities according to their true nature, New measurement methods and international accounting expertise, including accounting for space activities, may be necessary. It may be possible for each country to benefit from some tax incentives in proportion to their contribution to space activities value creation within the space economy. Additionally, there is a need for an independent organization to manage the taxation process of space activities, which will ensure the activities of working groups established by member states select and authorize personnel. In this regard, global organizations such as the International Federation of Accountants, IFAC, the Organization for Economic Cooperation and Development, OECD, and United Nations and the World Bank can be suggested. Thanks all, and if there is any question.
Okay. Yes, please. You can.
Thank you very much for the presentation. In fact, I listened to this similar one last year also. It was perfect. I did enjoy a lot. Just for your information, in China, Beijing University has started a master program, covers this topic as well, very first time.
Oh.
They also understood the importance of this kind of subjects. Just for your information.
Thank you. Thank you.
Much welcome.
Thank you.
Okay. Thank you. Any other question or comment from the audience?
Yes.
İnci. İnci miydi?
Yes.
İsmini
İnci Hanım
yes.
için, yes, for Miss Inji. When I listen you, immediately I recalled a sci-fi movie, Star Wars.
Yeah.
China looked like a kind of dark side of the force, and the Western world, let's say, not only one country, United States, Western side is the good side of the force, Jedis perhaps. As a person living in China last 4 years, I really experienced from the very first hand. Yes, they went the other side of moon and they have lots of projects. I'm closely working with CNSA, Chinese National Space Administration, because it is part of my job. And yes, they are very open to all international community. Yes, also you are right. Somehow they have a kind of cultural secret side, but that secrecy is not coming so conspiracy theories, their own behavior, a kind of. But at the same time, what I noticed that they are really very open. Once you approach them, they open everything almost. And for example, I am involved into their ILRS program, which is the sister project of Artemis. As you know, Chinese side usually sometimes copy the projects, also ideas, but this kind of things also gives a kind of power to them, because on the way they discover another side of the projects and they do it. For example, ILRS will be completely a robotic project on the moon, and they will finish it in 2035. They also invited lots of nations. Of course, this scared the other part of the world. What I see, in fact. Anyway, I like this kind of space race between the sides, let's say. And at the end, I'm sure that all human beings will benefit it. So when even I am in some missions, or if I work even in the one side geographically, I find this kind of competition very useful for humankind. But when I hear you, I might be wrong. If I am wrong, please forgive me. but I sense a kind of conspiracy theory, which I find it a little bit unfair, to be honest.
Okay.
So, and what I see from your presentations, usually your sources are from Western world. In Turkey, as a Turkish citizens, we should be open to all of them. And yes, your analysis, most of them were right, in fact. So I liked also, in a way. But let's try to be fair, even to the darkest side. Because yes, they reached to the dark side of the moon, and they are going to put lots of satellites, some kind of Starlink satellites, to use a relay station to be able to communicate with the tools at the back of the moon. In fact, this is an ongoing project. And this will be happening. We cannot run away from that. And there is no bad thing about that. And every country, I'm sure, that inventing some dark projects secretly. This is pretty natural, but this doesn't mean that they are going to destroy the other side, or other side is going to destroy other side. So forget about that.
Yeah.
Anyway, thank you.
Thank you, thank you. The dark side would be Americans, not China. Because, as you know, the HARP project and HARP project and Thor project so much discussed after the earthquake in Turkey. And therefore, actually, maybe Americans are more dangerous than the China for Turkey.
I understand. I'm not, in fact, focusing on to our country, but also those projects are a kind of projects. I'm sure there was a reason to start them, but I don't think that they also achieved whatever they wanted. So it's
mostly Americans making exaggerations because they need to some trades for the passing to some budgets from the Senate, as you know, because the political system are completely different. They convince the senator about the budgets. Therefore, they all the time in the Pentagon papers, the exaggerations about the Chinese trade. Yes. But China has also so much usable projects like artificial lunar project, artificial sun project, and also to protect with shield of all the earth from the radiations of the sun, or also changing the rotations of the earth, maybe turning to the earth as a space craft to go to the other part of the deep space. These are the projects, as you know, even you are China.
This is only the sci-fi stories, believe me. No one can stop the Earth's rotation and then make it reverse, first of all. At least we don't have this kind of technology, and we don't have this kind of science. And even if we have it, I wouldn't recommend to anyone, because everyone dies. The second thing, using the Earth as a kind of spaceship, this is one of the movies in China now, Wandering Earth.
Yes, I mentioned this one.
The second one, just also there are so many scientific mistakes.
Maybe
but
nuclear fusion facilities might be possible for that spacecraft of the Earth projects, because they have already tested tokamak for the producing nuclear fusion energy in China. Therefore, maybe these some secrecy zones in everywhere in the world might be these tokamak projects for the protect the Earth from the sun radiations, or maybe sun turn to be black hole in the future, and we have to move from here, from that Milky Way, and to find the other place from the deep side. actually this is so much futuristic projects, but I believe that they are focused on, and also hypersonic missiles, the MIT, they work there, and then the Chinese scientists come to the China and become the founder of the Chinese space.
Yes,
therefore,
that's
all
true.
the time when you look at their collaborations of the United States scientific groups, they achieved this
At the
everything.
back hand, they are hand in hand.
Yes, and
Even the
but
Russia.
these exaggerations all the time, the Pentagon, when they made the same for Russia in the past in Soviet Union, because they need to budgets for the extra huge budgets for this race. But now the Biden administration is thinking differently than the Republicans, because the first one is the protect the human rights and democracy and other things. Therefore, they postponed the Artemis project for 1 year. Therefore, they need convincing the senator about the traits of China. Therefore, all the time say China is secretly improving new weapons and attacks. But so most of them, of course, you are not right. But all the time, they are so much making black propaganda, misperceptions, creations of many.
To be honest, both sides are doing that to each other.
Sorry for the interruption, but we need to continue to another presentation because our time is limited.
Okay, thank you so much.
So we need to use this limited time as well. Now, final presentation will be from India. Mr. Sandeep Bhatt will present the paper titled Evaluating Private Space Tourism in the Backdrop of UN Space Treaties. Mr. Sandeep is from Center for Aviation and Space Laws, Director, and the National University of Juridical Sciences, Salt Lake City, Kolkata, India. And this presentation will be online again. And can you hear us, Sandeep, Mr. Sandeep?
Yes, I can hear you. Can you hear me?
Yes, we hear you, and you can start your presentation.
Okay.
You have 15 minutes, please. You can use your time
Sure,
as you wish.
I will complete within 15 minutes. Yes.
Okay, thank you.
Is my screen visible?
Sorry? You can, yes, we see your presentation on the screen now.
Just a second. I'll just actually.
We can see it.
Yeah, I will just share once again. I'll try once more.
No, we can see your presentation. Yes. Yes, it is there. Okay.
Okay.
You can start.
All right.
Thank you.
Oh, thank you. Thank you so much. A very warm good evening to all of you from India. It's indeed a great privilege for me to be part of this particular international conference. I would have loved to actually be there physically, but unfortunately, fortunately or unfortunately, because I have a conference tomorrow, I'm organizing it from here in the India. I have already shared the link in the chat box here. So if anyone is interested, you can also actually be part of my conference tomorrow, which is again on aviation and space dispute settlement. So some of you might be interested in terms of actually being part of it. Right, so today I'll be speaking on the space tourism, private space tourism. I think the previous presenter has already spoken with respect to the taxation. I'll be discussing more in terms of international treaties. My focus is on the UN space treaties, how exactly we can evaluate the private space tourism. Of course, there are a lot of other issues at the domestic level. So taxation is one of them, then licensing, authorization, supervision, multiple issues crop up at actually the domestic level. I'm not going to touch upon them, rather my focus is more in terms of actually the UN space treaties. As all of us are aware of, Dennis Tito maybe actually started a new era in the field of space activities, because he happened to be the first space tourist in 2001. And thereafterwards, 6 more tourists entered into the outer space, went to the International Space Station between 2001 and 2009. Space Adventures also became the first private company to join this new age activity, space tourism, along with the Roscosmos in 2003. And it has been actually the partnering with Roscosmos continuously since then. 2010 Roscosmos took a kind of a break from the space tourism activities. They wanted to develop their technology. They had multiple other reasons why actually they wanted to take a short break from carrying on the space tourism activities. But this short break became actually quite a long break, and Roscosmos did not actually carry on the space tourism, private space tourism activities subsequently. And this became an opportunity for the private players. A lot of efforts or a lot of research and development took place in terms of both orbital and suborbital space tourism. 2021, we saw again a kind of a new era in the space activities, with three of the giants in the private space sector, Virgin Galactic, Blue Origin, and SpaceX, entering into the race of the space tourism. The CEOs of the companies entering that in, showing as if actually it is very, very safe to go to the space, and also private space tourism kick-started that afterwards. And in the last 2 years, you see a lot of actually the private players, private tourists entering into the outer space. There is also a debate with respect to which law is applicable in case of space tourism. Is it aviation law or the space law? Especially because there is a use of the aerospace vehicles in terms of the space tourism. So precisely because of that reason, there are debates as to should it be aviation law or should it be space law. I will not indulge in that debate. Rather, I will focus primarily in terms of actually looking from the space law perspective. How exactly the tourism has got certain issues under the United Nations space treaties, and what could be the answer for dealing with those issues. That's what I will just focus upon. First of all, we find a kind of a concern under Article 6 of the Outer Space Treaty, which basically speaks about authorization and continued supervision. As per Article 6, every space activity, whether it is public or private, even if it is carried on by the non-governmental entities, it should be authorized and continuously supervised by an appropriate state party to the treaty. Let me tell you, there is a singular which has been used. It mentions appropriate state party to the treaty. It doesn't mention appropriate state parties to the treaty. So which is this appropriate state? Who is supposed to authorize and who is supposed to continuously supervise a private activity like the space tourism? That itself becomes debatable. This is because there are multiple stakeholders who are involved in the private space tourism. We have an operator, right? Operator like SpaceX or maybe say Virgin Galactic. So they may be the operators. There might also be a possibility that the space vehicle might belong to some other company. There is also a possibility of leasing, cross-border leasing is possible. Private space tourists might also belong to yet another country. So consequently, which is this appropriate state party which has to authorize and continuously supervise a space tourism becomes a debatable issue under Article 6 of the Outer Space Treaty. And interestingly, Article 6 not only speaks about authorization and continued supervision, it also attributes the state responsibility with respect to any failure. State party to the Outer Space Treaty is responsible at the international level with respect to the activities, whether it is governmental or non-governmental activity. So that is why one need to be really careful in terms of actually implementing the proper system of authorization and continued supervision. Otherwise, there is a possibility of attracting the state responsibility under Article 6 of the Outer Space Treaty. Second, registration. We have the Registration Convention 1975, one of the UN space treaties. There is a requirement of a dual registration. Space object has to be registered in the national registry as well as in the UN registry. And this registration has to happen after the object has been launched into the outer space or beyond. If you look into Article 2 of the Registration Convention, it categorically mentions this. Now, there are a couple of questions with respect to this. First, who is supposed to register? If we go through Article 2 of the Registration Convention, it says the launching state should go for the registration. And 2.2 says if there are multiple launching states, because actually launching state has got a very wide definition. Both Liability Convention and Registration Convention say that launching state includes a state which actually launches the satellite, state which procures the launching, state whose territory has been used, and state whose facility has been used. So all four categories of the states do come within the ambit of definition of launching state. So in a space tourism, there would be multiple states who would come within the ambit of this definition. Because it might have been launched from one country's territory, operator might belong to yet another country, and the tourist might belong to some other country. So all of them might come within the ambit of definition of launching state. And it is all private arrangements, there would not be any state arrangement. Which state is going to register, that itself becomes a kind of a question under the registration convention. Then, when it is supposed to be registered, Article 2 says that once the space object has been launched into the Earth orbit or beyond. But here, in case of space tourism, it might be very, very short-term stay in the outer space. Maybe for a few minutes, it might also be for a few hours. Where is the scope for registration? After launching a satellite or maybe a space tourism vehicle into the outer space or maybe beyond the Earth orbit, there would not be any time available for the purpose of registration or even the deregistration. Article 4 of the Registration Convention also speaks about the process of deregistration from the UN registry. So this registration and deregistration cannot be effectively implemented in a activity like the private space tourism, since there would be very short-term stay in the outer space. And this failure to register the space object has got a serious problem in terms of space traffic management. Because the registration convention is that for the purpose of ensuring transparency. Where exactly the space objects of different countries are located, which orbit is being used. So that is very important for the purpose of ensuring that subsequent launch or subsequent activities would not result in any kind of an accident. It would not result in any kind of a collision in outer space. So the very purpose of registration convention in terms of transparency would be defeated if the private space tourism vehicles are actually frequently moving into the Earth orbit and revolving around the Earth. So again, we need to consider actually how exactly the transparency can be built, and then the space traffic management can be done in a better manner in terms of the private space tourism. Next issue is in terms of emergency assistance to the private space tourists. We have the Rescue Agreement 1968, which primarily comes out of Article 5 of the Outer Space Treaty. And Article 5 of the Outer Space Treaty speaks about astronauts as the envoys of the mankind. They have the elevated status of being an envoy of a mankind. And by virtue of that, they are also entitled to emergency assistance. Article 5 says that, and it has also been elaborated under the Rescue Agreement 1968. While elaborating, Rescue Agreement not just confines itself to astronaut, but also extends to personnel. It says there's a requirement of providing the assistance even to the personnel on board the space object. Now the question is whether this term personnel includes anyone or everyone on board the space object, or is it confined to only those people who are going to the outer space for the purpose of furthering the interest of mankind? Just the previous speaker just mentioned that Article 1 of the Outer Space Treaty speaks about carrying on the activities for the better interest of the mankind as a whole. Article 1 mentions about it. And astronauts as envoys of the mankind also emanates out of that presumption that astronaut is a person who is going there to the outer space for carrying on certain activities for the benefit of all of us. So that's the reason why an emergency assistance provision has been provided there. Even the Rescue Agreement, interestingly, if you look into the provisions of it, it does not provide for the cost reimbursement for the purpose of actually providing emergency assistance to the personnel and returning them back to the launching authority. There is no provision on that. So that is why the question arises, a private space tourist who is going to the outer space for his own or her own enjoyment, can they avail this kind of a provision in terms of emergency assistance? Because at the end of the day, state which is providing the emergency assistance and returning the private space tourist to the launching authority might not be able to get back the cost of actually the assistance and the return. So how far it is justifiable, and is the Rescue Agreement imposes a legal obligation with respect to protecting the private space tourists in case of emergency, or is it just a kind of a moral consideration or a humanitarian consideration as reflected in the preamble of the Rescue Agreement is a debatable issue. Next, liability. One of the most significant aspects with respect to the space activities is the fixation of liability. And if you look into the Outer Space Treaty and the Liability Convention, liability for any damage caused out of the space activities is imposed on the launching state or launching states. Joint and several liability when there are multiple launching states. So liability conventions mentions about joint and several liability. Now in an activity like a private space tourism, as I have already pointed out, there may be a possibility of multiple states coming within the ambit of definition of launching state. Once that is the case, there are multiple states who would also be falling within the ambit of the liability. And since it's a joint and several liability, victim can claim compensation from any one of them. Interestingly, if say, for example, a private space tourist belongs to a particular country and he gets launched from a space object of another country, a developed country, the former country might not even be knowing that it's a citizen or it's a national is being launched from another country, but still that country might be liable under the liability convention since it comes within the ambit of the launching state. Especially if you look into the definition of procurement of launch in the definition of launching state, there is every possibility that a tourist who is sponsoring the space mission would come within the ambit of the procurement. So given that factor, liability might be imposed by a private player's activity on a state, even without the state not knowing about actually such kind of a liability. Next.
And, Professor Sandeep, your time is about to up. Can you just sum up in 3 or 4 minutes, please?
This is my last slide, actually.
Okay, thank you.
Yeah, this is my last slide. Right. So, protection of the space environment. Tourism has always been a major concern, whether it is on Earth or maybe anywhere else. Actually, it has always been a concern in terms of environmental protection. The places have become actually the garbage bins, especially due to the people not having the responsibility to protect the environment after their recreation. So in outer space also, if this thing happens, right, so maybe throwing something or maybe actually littering something in the outer space, that is something which is disastrous, especially because outer space is not having dense atmosphere like the Earth atmosphere. Consequently, any kind of a damage which has been caused in the outer space might be having a long-standing effect. Article 9 of the Outer Space Treaty says about actually the not having harmful contamination of the outer space, but how far it is effective, how far actually the protection of outer space environment happens out of Article 9 of the Outer Space Treaty is a debatable issue. Last thing is about the jurisdictional issues. If we look into Article 8 of the Outer Space Treaty, it says that state of registry shall retain the jurisdiction over the space objects and the personnel thereof. So this is the wordings of Article 8 of the Outer Space Treaty. So state of registry shall retain the jurisdiction. It's a kind of an obligation which has been mentioned under Article 8. It shall retain the jurisdiction and control over the space objects and the personnel thereof. If you look carefully into this provision, it combines two kinds of jurisdiction. There is a jurisdiction on the space object, which is a quasi-territorial jurisdiction. And there is also jurisdiction on the personnel thereof. That is a personal jurisdiction. So on the personnel also, even if the person belongs to some other country, there is a jurisdiction on the state of registration of the space object. Now this is tricky because this combination of two jurisdictions has not been made with the hierarchy. Suppose if a space tourist from country A goes to the outer space, right? The space vehicle or maybe the tourism vehicle is from country A. It's a space object, so it goes to the outer space. And then he enters into the space station belonging to country B, another station in the outer space, country B. So he enters therein and does some kind of an activity, maybe a tort or a crime he commits therein. Who has the jurisdiction is a debatable issue. Because under Article 8, both can exercise the jurisdiction. A can exercise the jurisdiction on the basis of actually the personal jurisdiction, B on the basis of actually the quasi-territorial jurisdiction. So both of them either claim the jurisdiction or alternatively, both of them actually point towards each other to exercise the jurisdiction, wherein they might not end up in exercise the jurisdiction at all. So that is why these are certain concerns, these are certain major concerns, I should say, which we are basically having in terms of the UN space treaties when we look from the private space tourism from the perspective of international law. That's all from my side. Thank you so much. Okay, and if you have any question, I'd be delighted to answer.
Thank you, Professor Sandeep. And any question for this presentation or comment? I think there is no question or comment for the presentation. Professor Sandeep, thank you again for for this insightful presentation from India.
It's my privilege. Thank you so much. Thank you so much.
Right. Thank you for the presentations. And I would like to invite Professor Faruk Kerem Giray, the Vice Dean of Faculty of Law and the member of the organizing committee, to present the certificates of the presenters. If we can take you to the before of the stage. Thank you. Would you please?
Can I also get it online?
we hope we are going to send an email, maybe. Thanks.
Thank you so much. Thank you so much.
Thank you.
My privilege.
Hocam en sonda. Sonunda kapanışta. Thank you. And now I would like to invite the Dean of Faculty of Economics, Professor Sayım Yorgun, for his closing remarks of the symposium.
Evet. Öncelikle çok teşekkür ediyorum. Evet, yoğun bir hazırlık ve uygulama sürecinin sonunda üçüncü sempozyumumuzda tamamlamış olmaktayız. Öncelikle bu güzel organizasyonun gerçekleştirilmesini 3 önemli kurumumuzla gerçekleştirdiğimizi ifade edeyim. İktisat Fakültemiz, Hukuk Fakültemiz ve üniversitemizin Gözlemevi, Uygulama ve Araştırma Merkezimizle birlikte yaptık. Emeği geçen herkese çok teşekkürler ediyorum. Bu toplantının şöyle bir mesajı var. Ben oturduğum yerden düşünürken şunu ifade etmem lazım. Bu sempozyumun sürdürülebilir olduğunu herhalde 3. sempozyumla artık güçlendirmiş olduk. Yine bir başka önemli husus, istatistikler önüme geldi. Ondan edindiğim intivayla bu düşünceyi sizlerle paylaşıyorum. Her sempozyumda bir öncekinin ilerisine doğru gidiyoruz, daha zenginleştiriyoruz, daha derinleştiriyoruz. Çünkü alan yeni bir alan. Dolayısıyla akademisyenlerimiz, uzmanlarımız, araştırmacılarımız çalıştıkça daha yeni bilgiler ortaya çıkıyor ve bu da önümüzdeki dönemi aydınlatacak adeta birer fener olarak bunları değerlendirebiliriz. Şu anda çok farkına varılmamış olabilir ama ülke açısından da çok önemli bir rol üstlendiğimizin altını çizeyim. Türkiye'de neredeyse uzay alanındaki kurumsallaşmayla paralel bir şekilde sempozyumun yürütüldüğünü bu vesileyle bir kez daha ifade etmek isterim. Katılımcıları değerlendirdiğimizde 4 davetli tebliğ sahibi olmak üzere katılıma baktığımızda 28 adet bildiri sunuldu. Gelen ülkelere baktığımızda, yani bildirimi sunan araştırmacılarımızın geldikleri ülkelere baktığımızda Fransa, Makedonya, Pakistan, Ukrayna, İran, Peru, Hindistan, Avustralya, İtalya başta olmak üzere ülkeler var. Ama önemli bir husus daha var. O da şu, Asya-Pasifik Uzay İşbirliği Örgütü'nün çok önemli bir katkısıyla da bu süreci yürüttüğümüzü söyleyebilirim. Genel sekreterini temsilen aramızda özellikle Ferhat Fikri Özeren'in şu ana kadar bizlerle birlikte olması ve bu süreci bizle birlikte yaşamış olması bizim açımızdan oldukça önemliydi. Yine hatırlayacaksınız, Türkiye Uzay Araştırma Ajansımızın Sayın Başkanı açılış konuşmasıyla aramızdaydı. Yine bu da çok önemli bir katkı olarak karşımızda duruyor. Sempozyumda sunulan bildirilere baktığımızda ekonomiden hukuka, hukuktan uzay bilimlerine doğru çok farklı alanlarda tebliğler sunuldu. Bir yönüyle turizme doğru bir açılım yaşadık. Bir yönüyle Erzurum'daki açılacak Gözlemevine doğru bir açılım yaşadık. Çin'deki uzay faaliyetlerinden tutun, uzay dünyası içerisinde ortaya çıkan etkileşimi gündeme getiren sunumlar, tebliğler burada dile getirildi. Bütün bunlar bize güç veriyor ve bu güçten hareket ederek de herhalde dördüncüsünü de açıklama zamanıdır diye düşünüyorum. Mayıs 2024 yılında 4. Uzay Sempozyumumuzu yapacağımızı şimdiden ifade edeyim. Ve bu sempozyumu yine biraz önce ifade ettiğim gibi ASPCO'nun çok kıymetli destekleriyle yapacağız. Asya-Pasifik Uzay İşbirliği Örgütü'nün desteğiyle yapacağız. Bu da bize önemli katkılar sunacaktır diye düşünüyoruz. Yine davetli konuşmacılarımızın olacağı bir planlama içerisinde olacağız. Siz katılımcıların da desteğine ihtiyacımız olduğunu bir daha ifade edeyim. Tekrar emeği geçenlere çok teşekkür ediyorum. Başta İktisat Fakültesi'nin hocalarına, idari personeline, Hukuk Fakültemizin hocalarına, idari personeline, Gözlemevimizin çok kıymetli hocalarına, üniversitemizin çok kıymetli personeline verdikleri desteklerden dolayı çok teşekkür ediyor. En içten sevgi, saygılarımı sunuyorum.
So this is the end of the third International Space Economy, Space Law and Space Science Symposium. Thank you very much and see you again next year. We would like to invite all of the participants for a picture to commemorate this day. Thank you.